A number of breaks. There's one in the morning, one in the afternoon, and then there's a lunch break. And there'll be coffee and things provided for you during those 2 breaks in the morning and afternoon. If you need to connect to the Wi-Fi so you can tweet about our event, the hashtag is SOTB18. And you just go to Conway Hall free and say, yes, I want to use the Wi-Fi. Very, very simple. So putting on an event like this is A, stressful, B, exciting, C, expensive. So to make it less expensive, we have these things called sponsors. The headline sponsor, who is actually paying for my words to appear in Squiz. So thank you to them. I work for them as well. But we've also got a big chunk of money from Binary Vision and Google Boxes. So when you've written something, your talk was amazing. And there's others as well. Thank you.
Cool. There's grid gap and grid column gap. It's in both directions. I can just use 30 pixels. So then you define tracks that take up a proportion of the available space, taking things like gutters into account. So with grid, there actually really isn't much need anymore to use percentage sizes and calc, because the FR unit does a lot of the heavy lifting for us. So this grid will be 4 columns, each taking up an equal proportion of the available space. Just to give you an example of that in action, if we have 3 columns, each of those 200 pixels wide, and 1 column, which is 1 FR unit, we get, and the 4th column is template columns properties, and we can also define, for example, if you're creating like a news feed, and you might be wanting to add items into that all the time, you don't know how long that's going to be. So grid auto rows allows us to define the height of any newly created when we place items. That's where both of those elements start. I'm naming line 4 main end, and I'm naming line 5 header end. Now, you can use any names for your lines, but if you suffix those line names with start and end, you get a grid area, which means we can do this. So we can just say, put our header in the header area, put our main in the main area, which is kind of nice. There's one more method of placing items that I want to mention, and that's using the grid template areas property. And this allows us to basically draw our grid with text. So in this case, I'm using H for header, M for main, A for aside. For any blank cells, you can use a full stop, or you can use a blank space. And you don't need to use single letters, you can use full words, so header or main or, triangle. I mean, it won't be a triangle, that's a stupid example. That was literally the first word that came into my head. Yeah, you can call them whatever you want. You can't call them numbers, as I found out to my detriment. Fun fact. So this can be quite useful. It's not something I tend to use super often, but for some people, this is kind of one of the major selling points of grid for them, and I can see why. It does make things really clear where you need to position them. And then when it comes to placing our items, all we need to do is reference that area. Nice and easy. Now onto CSS variables or custom properties. So I tend to refer to them as CSS variables, but because to me, they behave a lot like variables in, SAS or JavaScript or whatever. That kind of, adds up in my brain. But I see them get referred to more and more now as custom properties, and I can kind of see why. So I think I might have to start calling them that as well. So you're probably familiar with variables if you're using SAS or less or one of the preprocessors, but CSS variables are not the same as preprocessor variables. They can't be used interchangeably. So one of the big differences is SAS and LESS variables are compiled in the pre-processing stage before your code hits the browser. And CSS variables are computed in the browser, and that has implications for how we can use them. So CSS variables can't be used for selector names or media queries. They can only be used for CSS property values, and hence they're known as custom properties. CSS variables are dynamic variables. So once they're set, their value isn't fixed. We can update them in CSS and JavaScript. To use a JavaScript analogy, preprocessor variables are a bit like const. So once you set them, that's it. That's what the variable is. Whereas CSS variables are a bit more like let. They can be reassigned, they can be scoped to a component or selector. This is how we declare a variable, and I'm declaring this variable bgcolor on the root element, which is the equivalent to the HTML element, but with higher specificity. And this is creating a global variable. You don't need to declare your variables on root. Sometimes it's a lot more useful to scope them to the selector. And this is how we use that variable in this component with the class of myComponent. So the background color of this component is going to be red. One thing that's really handy to do with CSS variables is to set defaults. So I'm giving this component, myComponent, a background color of bgcolor. But if that variable can't be found, for example, it's not been assigned yet, then the background color will be orange. And then if my component is the last child, I'm actually defining that variable bgcolor as red. So for the last child, the background color will be red. That's quite simple. There's a slightly better example here. So I have a box with, which I'm doing exactly the same thing with. I'm saying I want this box to have a background color of bgcolor. If bgcolor can't be found, then I want it to be orange. And then in this purple selector, I'm assigning bgcolor a value of Rebecca Purple. In the code on the left, if I just have a box on its own, it's going to be orange. In the code on the right, if I have a box inside this purple selector, it's going to be Rebecca Purple, because I've scoped that variable to the purple selector. So now I'm going to talk about combining CSS variables with CSS grid. And variables can make complex layouts easier to manage. And the first way they can do that is by managing complex grid declarations. This is a grid declaration that I wrote for a component that I built at MUD, the agency I work with. It's for Warner Brothers Studios, a project we worked on. And as you can see, the grid template columns and grid template rows properties have got quite long. I'm using quite a few line names. I'm also using, it's also a 24-column grid, which is insane. No one should use 24 columns in their grids, in my opinion. I'm also using the min-max function, which I just want to kind of divert into a little bit. Min-max function is another really useful function in grid, and that basically does exactly what it says. It allows you to define a minimum size and a maximum size for your tracks. And what this is doing here is I have 24 columns, which will have a minimum size of 0 and a maximum size of 30 pixels, and they will basically form our central wrapper area. They'll grow to 30 pixels and no larger. Then I have a flexible column either side of that, which will expand to fill up all the available space in the viewport. And what that means is we can place items on that grid that align to a central wrapper that's being used throughout the site, and we can also place items that break out and fill the viewport, or align to the edge of the viewport if we want to. So that's super handy. I also have a blog post on it. I can link to that in one of the later slides as well. So going back to how CSS variables can help us with these crazy, complicated grid declarations. If I want to update any of these grid template columns and grid template rows properties, then I basically need to write out that whole declaration all over again, which can end up getting quite messy in your CSS file, make the code like quite kind of complex to go through and debug. So what I can do is I can define some variables, column width and the gutter width. And what this means is, say, after 1600 pixels, I want to make our columns that bit wider in the central wrapper area, and I also want larger gutters as well. So after 1600 pixels, I'm changing the column width and gutter variables. And then I pass those variables into our grid template columns and our grid gap declarations. And that means I don't need to write that media query within the grid component. That's already done for us. I don't need to write that grid declaration all over again. So that's kind of nice. I learned this after I built a 700-line SAS file for this component. So I kind of wish I'd realized it earlier. Another way variables can help us is by managing component variants. To use another example, we have this article with a class of grid. We have a figure and a div with a class of grid text. So we're building basically a simple text and image component. We have our image on the left and text on the right. In the background, you can see, hopefully, the column outlines, and that's just for illustration purposes. And that also kind of shows what I mean with the with the min-max function and the max width wrapper. Those two columns either side will be expanding to fill all the available space in the viewport, and the central columns will stay as a max width. So that's our grid declaration. It's a bit like the one we saw previously, except a little bit simpler. We only have 12 columns for one thing, which is a lot nicer. And I'm naming a couple of grid lines. I'm naming the start and end lines, and also the wrapper start and wrapper end lines, so that we can place things on that max width wrapper. And this is how I'm placing my child items on that grid. So I'm using a mixture of line names and numbers, and the span keyword. And the reason I'm using the span keyword for our text element is because in my component variants, which we'll see in a moment, I want the text block to remain spanning the same number of columns for each one. I want to vary some other stuff, but I want to keep that the same. And that's a really good way of making sure that when you're placing things by start line and end line, it can sometimes get a bit confusing as to, do I need to place it on this line or that line, but I want this to be the same as the previous thing. Span keeps that a bit cleaner, because I know that I always want it to span for, regardless of where I position it. So these are our different component variants that I want to build, the different layouts. So the first one is the same as the layout we've already built, and then we have 3 different variants. I'm using the same underlying grid and most of the same CSS, but I just want to place the items on the grid slightly differently. So what I can do here is I can use variables for the grid column property on each of these grid items. So for the image, I want it to start at the image start value, but if that can't be found, then I want it to start at wrapper start and spanning whatever the image span value is, but if not, start at 6. And I'm doing a similar thing with the text component. And this means that if I don't declare the variables, the defaults will be used, which is the values that we had in our initial component. Then to create those different variants, all I need to do is update the variables. So So grid C, the last one, I actually don't need to change, I only need to change the image span variable because everything else is the same. It's just going to be like a narrower image or wider. I can't remember. So I think that's a quite nice way of managing variance. It means that we can keep our grid code a little bit cleaner, and it means we can avoid using descendant selectors or creating new classes for styling our grids. We can just pass the variable in, or declare the variable at the component level, and it will be scoped to that component. And this is quite a simple example, so it doesn't save us loads and loads of lines of code, but in my experience, once you've got sort of all the other kind of styling mixed in, and you have like @ supports if you want to provide fallbacks for your grid layout, then this just really helps to keep the code clean and easy to debug. And I'll just show you a quick demo of these layouts in action, hopefully. That's a different thing. So then we have our 4 different component variants. And again, there'll be a link to this demo on the slide, so you can dig into the code if you want to. There we go. So just one more thing I want to talk about is CSS variables and JavaScript. And updating CSS variables with JavaScript allows us some quite interesting creative possibilities. To get the property value, we use getComputedStyle and getPropertyValue and your variable name. And that returns a string, is one thing to mention. So for the demo I'm about to show you, I'm actually converting that to a number or to an integer in order to perform calculations on it. And to set the property value, use element, style, and set property, and your variable name and the value you want to set it to. So it's not a million miles away from any other CSS property. So I'm just going to show you this quick demo. Not that one. So this is a CSS grid background generator that I made specifically with the purpose of creating some nice backgrounds for my slides. So when you click the Generate Layout button, the variables for each of those child items, the start line and the span values will be updated with a random number. So we're just going to keep getting random layouts. I'm also using variables for the CSS blur filter, so they'll all be blurred to a different degree. And if you hit color shuffle, then you can just change up the gradient randomly, and that's generating random variables for the hue in the HSL color function in my linear gradient. So in this demo, in the code on the side, you can see, I mean, you probably can't see from there, but I'll send you the link anyway. So the code on the side is showing us what those computed variables are going to be each time I change them. So just to wrap up, if you're interested in knowing more about CSS Grid, here are some links to some really great resources. Rachel, Andrew, and Jen Simmons are like the CSS Grid people and have written and talked about like everything to do with CSS Grid. So anything they make, I thoroughly recommend. Rachel, Andrew has this Grid by Example, which has a lot of articles and examples of layouts you can build with Grid. And Jen Simmons has, and my own blog, CSS in Real Life, I have some articles about CSS Grid and specifically using variables, and I talked about earlier, if you want to have a look at that as well. So that's everything from me. Thanks for listening, and here's my Twitters as well.
Wow. That was absolutely amazing. I've learned so much in 20 minutes, 25 minutes. Thank you so much. Oh, excuse me. I'm just going to do some magic, switching over computers before I introduce Dr. Ben. But whilst I do that, something quite exciting has happened in this time. We've brought to you a new browser. Well, it's not a new browser, but it's a new browser to us, to state of the browser. So, Dr. Ben has come from Brave, which I'm sure he's going to talk to you about that. It was developed by Brendan, who built JavaScript. I think we're just about ready. Oh, look at that, I'm not logged in. Cool.
Yeah, good to
Okay,
go. Thanks.
so we'll just make sure this video and I'm out of here. Thank you very much, Doctor.
Thanks very much. It's wonderful to be here. So how many of you have tried Brave? Yay, lots of you. Great, this is wonderful. So I'm here to tell you about all sorts of things. So actually, primarily these three things. I'll tell you about the browser and why, in a sense, you need a new browser, or you might need a new browser. I'll tell you about BAT, the basic attention token, and why you might care about that. And lastly, I'll tell you about both our progress so far and about some of the things that are coming up. So this wonderful world that some people call Web 3.0 or Web of Value, I'll give you some hints about that. Arguably, most of us don't quite know what's coming just yet, but hopefully I'll provide some excitement for the morning as well. So here's a glimpse of our vision. We are focusing on privacy. We want to provide a private by default browsing for the end user. Yeah, we feel quite strongly that the browsing that we have today is not something that we wanted in the first place. I'll tell you about all sorts of shenanigans with third parties. Did you hear about the British Airways hack from just about 24 hours ago? Yeah, do you know what was at fault there? I mean, do you know the culprit? Well, okay, we'll talk about that in just a few minutes. So hold on to that thought. So the first goal clearly was not enough. So we have a second goal, which is we want to reform or disrupt digital advertising. The way advertising is done online, we want to do it differently. We want to do it in a way that's more effective and also in a way that's more privacy preserving as well. And I'll show you how we plan to do that. And as part of that, we have this crazy idea, well, one of many really, which is that we want to compensate users for their attention. We want to pay users for their attention quite directly. So as you'll see, if users choose to opt in into our ad infrastructure or our ad ecosystem, we'll compensate them for their attention. How will we do that? We'll use our token to do so. And I'll start connecting these things in just a few minutes so that these ideas hopefully will take hold and come together nicely. But before I do that, let's start here. So this is a website from a couple of months ago. This is before GDPR. Remember the days before GDPR? Yes, most of you were alive then, yeah, good. So this is The Economist. This is a typical news site, and as a typical news site, it has all sorts of third-party trackers. And if you use an extension like this one over here, Ghostery, it will tell you about how many trackers it's got. So in this case, there are about 30 different trackers that have to do with advertising, of course, which is one of the primary goals, but not only. There is analytics, there is site optimization, there is site personalization, and so on and so forth. So in a sense, together with the first-party site, which is The Economist, the site that you want to interact with, there's a whole bunch of others that have come along for the ride, if you will. And it adds up to be a fairly significant violation of end-user privacy because these trackers are not only on this site, they're all across the web. And why are they doing that? Well, it's largely clear, right? So one of the reasons for that is they want to build profiles of the end user by observing how they travel from one site to the next, and so forth. And why would they want? Ad targeting is one of the primary goals. Turns out that you don't actually have to do it this way to achieve similar results, and in fact better results as well, as I'll hopefully show to you also. But this is the situation we have now, which is to say, oftentimes because of this ad tech, this is the collective term for what we just saw, yeah? Things are a lot slower than they need to be. So on a mobile browser, on a relatively slow connection, you might see slowdowns of 5 times slower than it needs to be. It's hugely invasive, so teamz.com tends to be like a poster child for how not to create websites. So for teamz.com at one point, they had over 100 different trackers partying on that website. Yeah, so remember, like, it's kind of like, a host and a bunch of parasites on the site, if you will. And then, of course, it can be quite expensive as well. So if you have a metered connection, right, you are paying by the megabyte, for example, some estimates show that you could be paying quite a lot more for this extra weight of edtech that you did not ask for in the first place. And last but not least, so this edtech is also a gateway to what's called malvertising, which is a way to deliver malware and ransomware through the channels that are used by ads. So the situation is kind of dire, right? So the situation is not so pleasant, which is why we've seen a rise of ad blockers. So this is the last decade of ad blocker usage. So we see it being a fairly fringe phenomenon down here. And by now, this is about a year ago, we see, almost close to 500 million people using ad blockers. So another show of hands. How many of you have tried an ad blocker? Okay, almost everybody actually, which is very typical, but not so. If you go outside, you'll see some exception to that rule. So it depends on the country. So for example, in Germany, the usage is quite high, maybe 40% and more. In the UK, it's something like 25%. In some parts of Asia, it's actually over 50%. Depends on how polluted the web is in that particular place. So in the UK, actually, the web is not actually as polluted as it used to be. There's a different phenomenon that's raising its not so pretty head, which is this, right? Paywalls. Have you seen these? Yeah? Frankly, just about any website, any news website, that is to say, that values its own content, has some sort of a paywall. And some of these things look like this, right? So this is one of them, here's another, and here's another. And in some cases, it's what I call a nag wall. So The Guardian, for example, right, they try to encourage you to sign up, and they try to guilt you into this as well, right? They don't insist, but they ask nicely, and they keep asking nicely until you're like, oh, I just give up. Different approaches, all sorts of psychological tricks, but like, what does this tell us? Well, so they want your money. Okay, so that's kind of obvious, right? But one other thing it tells us as well is that the ad approach that's been there for over a decade now, right? What we saw with The Economist, right? So basically banner ads at the top of the website and to the right of the content as well, sometimes at the bottom also. These things don't work so well. So for a typical banner ad, for a typical display ad, what do you think the click-through rates are? Any guesses? Like percentage points, yeah? Yes, sir, in the back. 5%. You're tremendously optimistic. I mean, you, sir, I envy your optimism. Please, somebody else. You. 1%, okay. Anybody? What? No, you have to raise your hand. You cannot play this game otherwise. Please. Less of 1,000. Well, you're slightly okay. So here's a pessimist in the audience. No, it's slightly better than that. Yes, anybody else? Anyone else? Yes, please. Huh? 0.5%, no, that's a bit too high. So you actually, the pessimist in the audience, was closer to the right answer than anybody else. So if you look at the estimates, this is roughly what we see. So these are some of the click-through rates. So this is, what is it, 8/100th of 1%. This is for a typical ad out there on a fairly random web page, averaged. Of course, once we start doing targeting, yeah, we see numbers that are a lot better. So for like Twitter, for example, these click-through rates go up quite significantly, by almost to an order of magnitude. For Facebook, which is a very effective walled garden, these click-through rates are significantly higher. Why? In part because they're better targeted, also in part because they're generally somewhat less annoying. If you want to read all about that, I recommend this book, Attention Merchants. It came out a little while back, but it's just as relevant today as it was when it came out. Okay, so now let's talk about Brave. And this is just kind of a preview of coming attractions, but something we are proud of is our adoption curve. And you know, we are a small browser, but we are making strides. So this is from August 27th, which is what, last week, the week before last, something like that. So we hit 10 million downloads on Android, right? So, you know, there are more and more people trying out the browser, and I'll tell you why this is interesting in the next several slides as well. And to do so, I need to switch gears slightly and tell you about BAT, or the basic attention token. So the ecosystem is broken, and this is what I tried to explain in the preceding several slides in the preceding several minutes. And it goes back to this Bermuda Triangle of advertising, right? So there are three types of parties here. So there are users who are treated like a product. There are publishers, which is to say owners of websites that you go to, whose life is not so sweet anymore. Why? Because their revenue is going down, which is why they're resorting to things like paywalls. They cannot monetize very well. And then advertisers, and you'd think that advertisers are doing spectacular, but the thing is that they're not, right? And part of the reason is because it's ad fraud. So ad fraud is a really huge problem in that space. So if they get a report that says, well, we just showed 10 million impressions, like how do they know that this is actually true? So ad fraud is a huge problem. There are some estimates there, yeah? So we're trying to address all of these problems at once because, well, I guess we try to be ambitious. Okay, so I talked about some of these pain. But ultimately, our to use a token in order to address these challenges, right? So the token becomes a medium of exchange in that Bermuda Triangle of the user, publisher, and advertiser. So when it comes to the user, we plan to use BAT to reward users for their attention. When it comes to publishers, publishers will receive BAT based on the amount of user attention. So and the revenue will increase, as it says here, as inefficient repayments, if you will, and I'll explain some of the details in the targeting. So let's think about targeting because of something I mentioned before. So understand what you like. So if you are a car enthusiast, for example, they want to learn that about articles about cars, that sort of thing. Great. Turns out that the browser out there. So the browser has like and what you don't like, intent in terms of purchase intent there is to see, and as such can build a much more accurate user model that can be used for purposes such as purchase. The reason they can target ads there so well is because they raised that much money in 20, and that's what enabled the project to function and grow, and we can hire people. We have over 70 people working on different parts of the browser and the BAT ecosystem now. And as you can read about on the website as well, so this project unfolds in 3 stages. The first stage This is what the Mercury stage, yeah? So we have been running that. So we deployed this some months ago, and we've been running that for a while now. This is the contributor stage. This is where you can put a little bit of cryptocurrency into the browser, and we give you a way to do so. On a monthly basis, for example, right? You put £5 worth of cryptocurrency into the browser, and that is spread across all the publishers that you visit. And I'll show you how that works. The next stage is where we have ads. We are planning to ship that in the upcoming several months. And of course, that's going to be exciting and scary at the same time. We'll see what happens. And the last stage is integration. So different interesting ways to integrate the browser and the website. And I'll give you several examples of that in the next several slides also. But one thing to think about is that, so suppose now pretty much all interesting content out there is paywalled, which is hugely annoying, isn't it? Because, well, now you have to figure out which newspapers to sign up for. So maybe you're willing to pay for the FT, but like how many of these subscriptions can you actually maintain? So what if instead of that, you'd be able to pay BAT to get access to these resources, but on a piecemeal basis? I might only want to read like 3 articles in the FT on a monthly basis. I don't want to sign up for the entire publication. It doesn't make any sense. So I'm willing to pay for what I spend, if you will, or for what I watch or view, but I wouldn't want to do it by holding on to dozens of subscriptions. It doesn't make sense. There are other models here as well. So the model I like is that you earn, say, 4 BAT by watching 4 ads during the day when you're at work. Maybe on a coffee break or something, yeah? And then you go home, and then you watch a movie by spending 3 BAT. So now you have 1 left that you save for tomorrow to do something else with, yeah? So this is a model where you can both earn the token and also redeem it within the same day. And that's quite a powerful model because it allows you to basically just enter this ecosystem by doing things that you would sort of do naturally more or less anyhow. So some screenshots from the browser here. This is your typical, I mean, this looks slightly different. This is from a couple months ago. The UI keeps changing on us because we have some wonderful designers who do that all the time. But this is your standard browser kind of configuration tab. And there's this payments thing over here that tells you how much your monthly budget is. It's not a lot, but it's just kind of, if you BAT here, yeah, so this is what it is in BAT, and this is what it is in US dollars, and we can show other currency as well. You can add some funds here as well. And these are the publishers that I compensate. And here's another one that's similar to that, but clearly from somebody else. And then here's another one of these as well, and there's another one also. And so here's my contribution statement for the month. So you can see that I spent a lot of time on this website and maybe these and the Wall Street Journal and so on and so forth. And this is the percentage and so on. And this is how much I've contributed. The point is that this data stays local to the end user. This data never leaves my machine. And this is a design principle that I highlighted in the beginning of doing this in a way that's privacy preserving. Yeah? So we don't know what you browse. Only you know what you browse. This is a statement for yourself if you're curious, but that's where it stands. This is where it stays. How do we implement? So just to give you a glimpse of some of the gory details, we use a system called Analyze. This is based on a research project from back in 2016. We have collaborated with these people quite extensively over the last 18 months to build up a system that allows us to learn about the totals, if you will, right? So we know how much total attention from brave users the Wall Street Journal has received, and we can aggregate it and figure out how much to pay the Wall Street Journal at the end of the month. But we do not know who these views come from. No? An important design principle here. A little bit about ads, and I don't want to dwell on this too much because the shape of these things keeps changing as we are getting closer and closer to actually releasing this. So maybe just like wait until the release and you'll see for yourselves. But so a little bit about what we are thinking here about the ads, primarily over here on this side of things, user ads. Something as well from our designer, something called Brave Rewards and ideas around micro-tipping and things like that. So this is, we'll see what of this actually makes into the final product. I don't want to make too many promises here. But the idea here is that, yes, so there's that. Watch out for that product coming to a browser near you in the next couple of months. But the principles I've already explained, which is to say, if you watch an ad, and typically this would be some sort of a video kind of thing. So maybe there'll be 10 seconds of video, 20 or something like that. At the end of that, you'll be compensated for having done so. Yeah, this will be maintained within your wallet that's in the browser, which is already quite a novel concept to many users, most users in fact. And then you'll be able to use that to gain access to content or potentially other things as well. We're working on some other ideas in this space also. If you care about this, go to look at the timeline, and I wanted to highlight some of these things here. It's actually more like 4 million monthlies at this point. Heavily mobile-based over here. This is one of the reasons why we are putting a lot more attention now into optimizations of the browser, because these things operate on slower connections and less powerful devices as well. Super important to us. Something else. This is actually 10. This is an old slide, so at this point at 10. Once we get to 20, I think we'll be, in a better shape still. Through a couple of these things. So we have a focus on privacy, so we have a partnership. I don't think this is working. A partnership with DuckDuckGo over there. We have a focus on crypto, so this is why we have MetaMask embedded in the browser, and we have had it for some time. And we have, I don't know, some colorful supporters like those guys over there on the right, so go and read about that. I don't have the time to capture this properly. So before I end, I wanted to talk about some of the road ahead. And the road ahead is, what some people call Web 3.0, and I like the phrase Web of Value. It's a phrase that appeals to me. So in addition to, I don't know, say things like social networking and responsive design, which are all wonderful, chances are we'll have some form or some forms of micropayments, or payments, if you will, existing on the web. And I wanted to give you a glimpse of that as well. So what do we have for that? Well, we have a wallet in the browser. You can put a little bit of money into that. You can store the BAT that you earned, that sort of thing. So that's wonderful. That's a fine start. We might support other currencies in that wallet as well as time goes by. But that's just the beginning. And in fact, it's a pretty significant psychological step for most users to understand what this wallet even means. Yeah? So that's one thing. We have MetaMask, I mentioned that before, so basically it allows you to connect to Ethereum dApps, so distributed apps. That's a nice bridge. We'll see if it stays that way, like in its present state. I'd love to see more dApps that are interesting. I don't think CryptoKitties on Ethereum are particularly on GitHub, which you can go and work on. It's interplanetary, right? Come on, it's right in the name. So these are some of the building blocks. I think there'll be many more coming down the pipe. I think this is just the beginning of us kind of building gateways and bridges towards some of the things we'll see coming out in the next couple of years. So I wanted to maybe leave you with this vision, which I think is maybe, because Twitter, just this web. Every time you like a tweet, there's a tiny micropayment that's directed to whomever wrote it. Every time you retweet somebody's comment or whatever, there's a tiny micropayment as well. Every time you comment, positively or negatively, there's a micropayment there as well. This is a way to capture attention in the form of cryptocurrency. This is a way to make something that's quite intangible fairly tangible, or at least virtual. Exciting. Yeah, great. Okay, so build other exciting examples. No time for that either. Yes, so we have an office in San Francisco. We also have an office in London and Shoreditch. So if you have friends or relatives who are looking for work, have them come and talk to me. That's it. I'm being kicked out, so thanks. No, I'm not being kicked out. Actually, not even 30 minutes. Look.
I wasn't kicking you out.
Oh,
I was
okay.
just making sure I was in the right space at the right time.
You're looking so threatening there. It's just, okay. Questions, or what do you want to do?
We'll leave questions to
Later.
So everybody's got a feedback form.
All right.
If you want to write a question, we'll put that in the box and we'll make sure that they get all of the questions. You can stay behind and talk to them in the pub, or the speakers will just be outside. So if you've got any questions, we can do that way. Thank you very much
Thank
to
you.
Dr. Ben and to Michelle for kicking off a fantastic start. Both of you, fantastic. We really appreciate it. We're going to take a quick break. If you want some refreshments outside, there should be some coffee, tea, etc., and maybe some cakes. I don't know what's appeared, but hopefully by magic, stuff has appeared out there. That'll be fantastic. Morena's just going to chase you around to get you into the room. There are seats at the front. You can see better. Should we do this?
I don't think like I have a choice anymore. Oh,
Okay.
This is way too close to my face.
So, welcome back. Hope you are suitably refreshed, inhaled nicotine, whatever it is you needed to do during that little brief break. We've now, in the next session, we've got 3 speakers, and then we let you free and let you run around and go get some lunch. And our first speaker is Sara.
Yes, I'm Sara. Thank you. Thank you so much. I want to point out that this is the first time that I actually give this talk, so if you have any feedback, bad or good, or bad, just please let me know. So my talk is called Stop the Div Fast, and you will understand what I mean. I can't see the thing. There we go. You'll understand what I mean. So, when I started coding, which was not that long ago, which was about like, I don't know, 6 years ago or something, everything that I coded was in tables, because that was the way we coded websites back then, and I mean after Dreamweaver. Dreamweaver was also a thing. I didn't do front page, so that was good. So when I started coding, everything was tables. And we're so much better now, right? Because we have a lot of like web frameworks, and React, and Vue, and all of the new stuff. But the thing is, if you really think about it, like really hard, if you just stop for 2 seconds and you think about this, we just changed tables to divs. Because everything on the web is now a fucking div. So that is literally what we do. And this is my talk. Thank you so much. Okay, joking. You're gonna put up with me for 20 more minutes. Good luck with that shit. Okay, so my name is Sara. Like it has been explicit, I am a developer advocate at YLD. I am really into horrible, horrible movies like Sharknado. Watching people fail on screen gives me life for some good reason. I don't know. And like a true Portuguese person, I am really into football. Also just moved out of Portugal, so yay. That was good. And now you're thinking, you are clearly exaggerating, right? Like, there is no way that we just went back to the same thing. It's not like history repeats itself or anything, right? Not at all. Look at Trump. What? So this is the website of Gmail, and if you look at it, don't look at my emails, okay? If you look at it, this is literally the worst. You're welcome. So, this is just a bunch of divs. Like, some of them don't even have classes, and the ones that have classes are like completely not classes at all. And so it actually literally gets the 2 worst parts of web development, which are divs and tables. And naming is apparently really fucking hard as well. And this is Dribble, and Dribble has exactly the same thing, which is literally everything is a div or an LI. No, actually it's OL, so that's good, they did that. Okay. So these are 2 websites that are heavily used like every single day. This one are as classes, because I remember that we used to, like, when I started coding again, and up until fairly recent, I think until like 2 years, I searched things for class names, and that is gone. And it's so hard to find things now. And if you look at the Dribble website, there is a div with an ID of header, and I think, I'm not sure, but I think that should be a header. I'm gonna go with a rule of thumb right now, okay? If you give a class to something or an ID to something that is an element, it should probably be that element, okay? So an A with a class of button should probably be a button. Just letting you know. So this is Twitter. We all love Twitter. Twitter is great, right? And as you can see, it also is a huge list of divs, which is pretty great. And it also has this beautiful thing that I have no idea what it is because this has too many divs right now. Where is that? Okay, it's in the next slide. Screw it. So it has a div with a role of main that I will try to find. There we go. Div with a role of main. And Also, if you put a role into something that is also an HTML element, I am pretty sure you should mean that HTML element instead of the role of an HTML element. Like, okay. So let's step back a little and think about one thing. So HTML5 came out in 2014. It was after I did, so that's something. It came out in 2000. Did someone clap? Thank you. I don't know who did. Get jokes on my thing. It came out in 2014, which it doesn't seem that long ago because to us we're still in 2012 in our minds. But the thing is, that was, oh shit, I didn't put it. So that was 4 years ago. We've had HTML5 for 4 years. And with HTML5, we had a bunch of new JavaScript things that are actually not HTML. And we also got a new set of tags. There are way more tags than this, and there are tags that I actually didn't know it existed. But we got stuff like this. I'm not gonna read it to you, but well, you can read stuff. Cool. Okay. So now I'm gonna do a thing, which is I'm gonna look at a tweet, and I'm gonna break that tweet down and see what is actually wrong and how we could improve this, how we could make the web a little bit more accessible, more SEO friendly, and just more fucking readable to humans who also code. Because I can't distinguish all those divs. I just literally can't. Okay, so on August 23rd, I lost my first flight ever, and it wasn't even in Amsterdam. It was in Heathrow. It could have been Luton or something, because the shuttle was delayed. But no, it was Heathrow, the best one. So this is a tweet. This is the visual representation of a tweet. And so a tweet has 3 parts. So it has the header that has information on it. So my name and my Twitter handle and when I lost the airplane. And it also has the contact, which literally just says that I missed my first flight ever. And it has the footer with actions. It also has the image, but as I realized, so Twitter, and do you know how they put the images on that side? It's a position absolute, and the rest of the things have a margin to just not, so I didn't want to put that in, because I didn't know how to explain that. I was just tables could do that. I'm not even saying use Flexbox, I'm literally just saying use floats. So we're gonna ignore the picture, okay? We're just gonna ignore that part. Okay, so what I'm gonna do is look at all of these 3 parts, except the picture, because that was kind of dumb. Because it's actually in the head, it's not, just look at it. You're gonna be like, what? And look at it in simplified Twitter code. So this is how their header looks like. So you have a div around everything, and then there's an A with an href of something, and a span that has a strong and a small with a class of time. What did I say about classes and things that have the same class as an HTML element? So how can we actually improve this to make this more readable for everyone, to make this way more accessible for everyone? So first of all, this is a header. Headers are not only for the header of your actual content. You can use headers for articles. Anything can actually have a header. So it's just a section, a header section, literally, it's that. So it's a header of a section. It doesn't have to be the thing. The only thing that is precisely only used once, should only be used once, it's a main. That should only be used for main landmarks. The rest of it is, you can use it whenever you want. I mean, not whenever you want, they have semantic meaning. You know what I mean. So don't go back to, okay, not the point. So you have a header, that is the header of the tweet. That could be a section or whatever you want. And then you have an A. So I removed the span because divs, spans have absolutely no semantic meaning other than the fact that they're really easy to write. And there's just 3 words, span. Okay. And they're really good for JavaScript, so when you just want that part of your, no, that's fine. So I removed that, because I have no idea why that's there. And so I added a strong the same way, and then I added time, which makes this, you can understand what I did does in a much simpler way than you can understand this. So you can see that this is a header that has a person associated with it and has a time. You can also add an author or something, but in this case, I think this is sufficiently decent enough. So this is the content. So the content is literally a div that has a paragraph in it. There's really not a lot you can do, so I just put it into a section because mains, like I said, should only be used once. Yeah, that's about it. So this is the footer. And I deleted a whole bunch of stuff from this footer. And so the first thing is that everything has 2 divs around everything, and then the button has a div inside of it, and I'm pretty sure that's not a thing. I'm not entirely sure, but from my from my college degree that I don't have, I am pretty sure this is not a thing. I'm pretty sure this one passed the W3C thing. But so for each of the elements in the footer, like for the like, retweet, and something, you have a div around everything. Divs are the new ULs. And then you have a button that has a div inside of it with a span that is an icon, and then you have a span with a number of people that liked it or retweeted it or replied to it. So it's just a bunch of divs and spans. Like the entire, okay. So this is how I made it look slightly better. So first of all, I don't have a lot of things to back this one up, but I think it's always a better idea to use SVGs instead of stuff like Font Awesome. I don't think there's any need to like bloat your people with more fonts that will probably may not load, and they may have a problem with that. And they're also not very good for accessibility, so you can just use SVGs. And if you give it, one thing about SVGs and accessibility is that if you don't give it a role of image, the thing that reads the websites, will read through the tags of the SVG, and you don't want that. Like, no one wants to read tags of SVGs, so if you put a role of image, it will now read the tag and all the tags, and you can add it as title to make it just like the like thing, and that's it. Oh my God, how did I forget the name of the thing? Not the point. Thank you. That's literally that makes sense. So, like I said, footers and headers and everything can be used in several positions. So in this case, I'm using a footer for the footer of the section, that is in this case the tweet. And then you have a UL and just have LIs. And I deleted the weird spans and divs because I think they were just there for layout. I'm pretty sure they were just there for layout reasons, which doesn't make any sense because they're not using Flexbox, but I don't know. So, and then you have a button with an SVG with a role of image, and then you just put the text in it. So that makes way more sense. It has way less HTML in it, and it just looks slightly better. Okay, the thing that I've started to realize is that, like, I remember when this came out in 2014, and we were all really excited about this. Like, I remember that everyone was really excited about semantic HTML and was really trying to make semantic HTML be a thing, and people trying to not use divs all the time and not to use spans all the time. And I like stopped and I was like, what happened? Why did we stop caring? The only conclusion that I've had is that frameworks happened. So I am a JavaScript developer. I'm a front-end developer, but I'm also a JavaScript developer, and I use React and I use Vue on a daily basis. And someone coughed and I was like, you don't belong here. I don't belong in any conference, dude. But I try my best to keep the thing still semantic, because that is the biggest misconception, is that people, I think, stopped caring a bit when frameworks started being a thing. And there are several reasons for that. There are way too many reasons for that, but I think this is something that we can combat. That's not a word. That we can fight all together. So one thing that React didn't allow for a very long time, I don't know who has used React here or uses it like in a daily basis. Okay, cool, okay, that's not bad. That's not bad at all. Okay, so for a long time, React didn't allow you to render more than one thing at the same time. What I mean by this is that something like this was impossible. You would get an error on your console saying that you can't render adjacent JSX elements. I still remember the exact error because this happened all the time to me. So this was not possible. And I want to point out that we're all very lazy. I'm very lazy, it's mostly me that is very lazy. And we could have thought about a way to split this into 3 different elements and find a way to just still do this. But the thing is, we are lazy. So instead of thinking about the best way, the most semantic way of achieving something, we just literally put a div around everything. And that worked all of a sudden, and there were no more errors, React didn't complain, we didn't have any accessibility testing for this kind of shit. So we're just like, oh great, you have a website, cool, dope. Display flex on that, all good. So this happened, and this was a problem. Up until, yeah, that's before we knew it, everything was a div. So there's this thing in React 16. So in React 16, the whole core team of React was like, peeps, we made the whole thing from scratch. It's super fast. It allows for all of this stuff. And also we have fragments, so you don't have to put a div around everything. And no one cared about the rest of the stuff they made. Everyone's just like, oh my God, fragments. And they were like, but we rewrote it. We're like, we don't care. We have fragments. So there is this new thing called fragments in React 16. So basically what fragments is that this actually doesn't render anything to the DOM. So what React 16 allowed was for you to return an array of elements. So when you return something like this, if you remove the fragment, you can also return an array and just put a comma between each element. So what a fragment does is literally that. So fragments don't render actually anything to DOM. They're completely DOM elements. They don't care. And, but I still find that a lot of people don't use fragments, either because they don't know about fragments or because they don't know about fragments. This is something that I think is very helpful in us trying to make the web a little bit more accessible and more maintainable and more fucking readable. So I really like Vue. I like React and I like Vue, and every time that I try to explain this, it's like trying to explain bisexuality to people, and it's very confusing. And they're like, that's not how it works. I'm like, that's exactly how it works. You can like two things at the same time. And they're like, wait, what? Everyone is so confused by this thing. So I really like Vue. I think Vue is like the Harry Potter of JavaScript frameworks, as in like it's really hard to find someone that hates Harry Potter because it's great. And it's really hard to find someone that hates Vue. You haven't used it, or you like it, or they're fanatics, but let's not get into that. So there's what? So there is bad news. The bad news in Vue is that there is no official way to support fragments. One thing that I think is sometimes misunderstood about Vue and React is that Vue is made, it has a core team, but it's mostly one dude who has 2 kids that does his entire thing. And he has help, but like the React is made in Facebook by a number of people that are way smarter than me, and they're good at what they do, and it's a completely different thing. So like Vue literally runs on a Patreon. It's a different type of thing. There are good news, which there are ways you can circumvent this, if that's a fucking word. So there is a thing called Vue Fragments, which doesn't support server-side rendering, but if you're not going to do that, that's fine. And you can use templates. Vue doesn't run on JSX. I mean, it can, but it runs on templates, and you can use them as DOM elements. What I mean by this is that, so for example, if I have, I have a thing. So this is Vue. Who knows Vue? This is Vue for the rest of you. So this is the JavaScript. And then you're like, oh my God, everything is in one file. I use CSS and JS. Everything is in one file anyway. So this is the JavaScript part, and I have an array that just has like stuff that uses Vue. And if you just v4 this and just add a template instead of a UL or something, you actually are not repeating code. So this just renders a dumb thing to the DOM like fragments do. So there are a lot of ways that you can go around this and make the web slightly better. So I think the most important thing that you can take away from this talk, if there is one, is that you should take care of your HTML. Like we take very much, we the JavaScript people, take, I don't know what that means, take a lot of care into our JavaScript. Like we're all super dry about our stuff. We're like no repeating code, and everything that can be a function will be a function. But then we get to JSX and we get on clicks on divs, and then we turn off all of the ESLint rules. Because there is actually a plugin for ESLint called JSX Accessibility or something that comes by default with Create React App. But yeah, that doesn't really work. We can make more readable code. I think we've been doing this with JavaScript, we've been trying to do this with CSS, and we kind of like somewhere along the way forgot about HTML being a thing, and forgot that you can just like literally put HTML in a document, and we can make way more readable code. We can make code that you look at it and it makes sense. That's what we want with JavaScript, and that's the thing we should get with HTML as well. Main point is that we can do better. We've made amazing tools as developers. We make amazing websites, and we made amazing stuff, but we forgot the basics. And I think it's important for us to sometimes remember the basics of where we started. And that sounded way deeper than I meant it to sound. And I also really like GraphQL. This is like the end of the talk. Yay, you're welcome. I also really like GraphQL, and GraphQL is bae. And I have a free course on the internet called letslearngraphql.com, where it's basically just a workshop that I did in Ukraine, in Kiev, that if you want to learn GraphQL, it's completely free, and you can take it on the internet. And you can also download it if you want. I don't know, it's fucking YouTube. You can do whatever you want. And thank you so much for having me, and have a great day. My slides are at stopdivfest.now.sh.
Wow. Thank you very much.
Thank you.
So it wouldn't be State of the Browser if somebody didn't mention Uncle Bruce. I went to see Uncle Bruce talk a long, long time ago. It was about 2008, and he talked about exactly what Sara has just mentioned. He said that in the olden days, when they were coming up with the specification for HTML5, they did a search of every single div name or every single ID on every single div on the top 1,000 websites in the world, and then collected that into working out what new elements should we create. And I can't agree more with what Sara has just said. We definitely should not be putting div ID name equals header, etc., etc., etc. Use the proper elements. The semantic web should win every single time. And I'm now ready to hand over to Rowan. Thank you.
Thank you. Aha. Hello. My name's Rowan. I'm a developer advocate at Google, and I have a slight confession. I made way too many slides, more than we can fit in half an hour. So what I'm going to do is I'm going to go through this very quickly, because I'm excited about it, and you can play it back at half speed on the live stream later. Okay. But before we jump in, I wanted to roll a brief pre-roll interstitial ad for you. If you have an in-real-life ad blocker, you may just see a black screen here. But I'm presenting from my Chromebook, which I didn't actually have a USB-C clicker for, so I wrote a little extension to map my Switch controller to the browser. So come talk to me about that afterwards. Okay, now into the talk then. People want to connect. They want to connect with each other, they want to connect with businesses, they want to connect with their little pets, or perhaps they want to connect to something larger than themselves. And how do we go about doing that, especially in today's world? Well, for the majority of us, we go about it like this. We connect through our mobile phones. I thought I would do, what do we call that now? A mashup? A remix? Anyway, the way we normally structure this is like this. We have a back end, we have a front end, and this is, you can tell this is an enterprise diagram because I have a cloud here. But as with most good enterprise architecture diagrams, this does not really map to reality. What we actually have is something like this. I've been fairly good today in that I think I only have 4 internet-connected devices on me. Does anyone just have 1 internet-connected device with them? Just 1. Wow, okay. You come tell me about work-life balance afterwards, because I need some help on that one. But it's not just the devices either. You've got to develop for several platforms, so you probably need to take care of Android, iOS, and web, and maybe it's not just web these days. Maybe we need to look at some other things, or maybe we care about wearables, so we've got to cover Android Wear, we've got to cover Apple Watch, and actually we're getting into the assistive age now, so you also need to think about voice actions. You should probably cover our social, email, your desktop app. China's getting really big now, so maybe you want to think about those. And in the next talk, we're also going to find out what we should be doing about virtual reality and augmented reality. Okay, this isn't focusing on the user. This is taking a kind of technology fetish approach to how we develop these things. And I don't advise that. A brief warning, there is a car analogy coming up, so if that's going to be a problem, look away now. But first of all, I'll just throw this out there. Apps and sites are dead. I'm not going to explain it. I'm not going to back it up. I'm just going to move on. So, this is the first car I ever drove, a 1984 Triumph Acclaim CD. And by drive, I mean a friend had it behind a barn and we drove it into a ditch. But what I want to kind of cover off of this is there's something important here, and it's this thing, okay? So I just need to enhance that. Okay, who knows what that is?
A choke, yeah, okay. That was very few hands that went up. So as an explanation here, before engines were fuel injected, you had to use the choke. And what the choke did was it adjusted the fuel-air ratio to the engine, because a cold engine needs more fuel in it to actually start. And the reason it looks like this is because when you pull that thing out, you're actually adjusting a valve that adjusts the air pressure. Now the thing is, this is a huge amount of information that we were pushing on users who all they wanted to do was get from A to B, right? But instead, we're suddenly teaching them that it's kind of like, oh, you can't just turn the key, you need to take the choke out, then turn the key, probably pump the accelerator a bit. Anyway, my point is, apps and sites are maybe not dead, but as far as users are concerned, these are implementation details. We've taught people about going to an app store. We've taught people about typing in a URL or following a link. We've tried to teach people what that little padlock icon means at the top of their browser and whether that should be important to them or not. But maybe that's the wrong thing. Maybe we shouldn't be focusing on teaching people all of this technological stuff when what they want to do is order a coffee or speak with their friend. I sort of fall into the camp of believing that there aren't any new ideas in computer science. We just kind of recycle the same ones every 10 years when we can like trade up things to get better consultancy rates. And what I'm seeing is a kind of move from this like app-centric idea back to a task-centric idea. So what I wanted to share with you over the course of this talk and the remaining, oh, wow, I'm actually like only 1 minute into my slot. Okay. I want to share some ways that you can think about taking a more task-centered approach to creating web apps or creating Android apps and where you can learn from each of those worlds. And I wanted to do this by shamelessly stealing some slides from our marketing team because they came up with, they came up with a Venn diagram which fit the title of my talk, so I was kind of like, well, that's going in. But I do feel like it actually sums up things fairly nicely. So when users are out and about trying to do something, they have an intent. So that's the kind of like, I want lunch, I want to speak to my friend, I want to get to the museum. And they have a context. And that context is not just, where they are and what they're feeling, it's things like what's their network connectivity, what device do they have on them, what are they doing at the moment, is their attention somewhere else, are they driving, are they walking? And then there's the immediacy. And the immediacy is, given those two things, what I want to do and my context for it, can I actually achieve it right now? Are you giving me the tools that I need to make that happen? And that is called, and this is where you maybe see that I took it from the sales team, that is what we call a micro moment. Okay, but micro moments, and the point about this is they have these fragmented user journeys. So 90% of people are using multiple screens for everyday activities. If you're booking a trip or you're planning an event, you're probably going across your phone and your laptop and your tablet, or maybe you're watching Netflix and you've got it going on your TV. And as well, when we're talking about e-commerce, it's not just going between devices. People are looking at their device and planning something before they go into a physical shop. And of course, there's also the contextual side of that as well. When they're in the store, they're also still looking at their device. I know on a regular basis, I will look at something and then I'll look it up on Amazon to see if it's cheaper, if I can. Anyway, some of the things, now, this is an example of, if you can cater for those use cases, right? If I can go into the shop and I know I can go to your website and it will actually be sensible enough to know that I'm in the store and maybe there's like a different experience you want to present to me, that's a good moment. But I've experienced things like this a little too often. So first of all, I want to watch a video, but it's some premium content video, and like a good web user, I want to pay a creator for what they've done rather than just finding an alternative download source. So I want to sign up to pay for it. So first thing I have to do is I have to be taught about this going through an account registration process. So I log up and I sign in, and when I do that, you tell me that I know you came to the web, but actually we're better at apps, so maybe you could download our app, or maybe that's a metric we need to drive, so we're trying to push app downloads. So I do that. I download the app. When I get into the app, you've just spent a lot of money on your onboarding video, and it's 3 minutes long, and you really want to make sure a lot of people see it, so I sit through that. Then you've forgotten that I was actually signed in before, so I've got to sign in again there. And by this point, I've forgotten what I was trying to do, what video I was trying to find, and maybe I just hop on to some other kind of site where I can get this sort of stuff for free. Okay, but that's enough complaining. Let's see what kind of things I think we could do differently to fix this. If this is what you're building, our enterprise diagram, this is what I actually want to feel. I just want to feel like I'm connecting to another person to get something done. Now, on the web, we have a handy way of doing this, which is URLs. I was thinking to myself, a URL is this human-readable identifier that allows the loading of data and code needed for that particular resource. Of course, if you've been looking around at the news recently, then whether this is really human-readable is up for debate. But developer-readable, I guess? There's a Venn diagram with developers and humans, I think. So, first, look up in the sky. It's a website. Okay, yeah, we'll skip that, because that's literally the point of the web, right? It's you hit a URL, and there's a page or a resource on the other side of it. But what if it was something else? And what if on the end of the URL is a C library? Or not quite that. This is where WebAssembly comes in. Who knows what WebAssembly is? Okay, reasonable. So WebAssembly is a binary format that basically allows sort of like compiled code to run client-side in your browser. And this enables a number of interesting things. So for example, you could go here and start this loading up in your browser, and in case you are getting a little bored during the talk, this will work on your phone as well, just as a hint. And you can start to do something like this, like run actual Windows 2000 in your browser. And why is this important? Because if you can do this, you can do incredibly valuable work. Now, I think at this point you may be thinking, okay, this is an interesting tech demo, but what does this have to do with real life? And haven't we seen this before with like Flash applets and Java applets? And in fact, just installing native apps where you point me to a big binary blob on the end of the URL. That doesn't really feel like the web. So something I'm a bit more excited about, though, is this kind of thing. So Surma on my team over in the London office has written a little blog or article here where he's gone through the process of wrapping an existing C library through Emscripten so that he can expose it to a page. And what he's been trying to do here is make use of the WebP image encoding library so that he can do that image encoding in the browser. And it looks a bit like this. So the first thing that you have to do is you write a bit of C code that just wraps the methods from the library that you want to expose. So you can see here we're exposing the create buffer and destroy buffer, and we're also exposing the encode method to, unsurprisingly, do some encoding. Then you run it through the compiler here. So I'm really only just showing you this as a sort of indication of the steps involved rather than expecting you to understand any of this. A nice little bit from this article is Surma pointed out that at that end bit where he's feeding it the C files, he wasn't really too sure which files it needed, so he just fed it everything. And the compiler is actually pretty good at optimizing that down to just what's being used. Once you've got that, you'll get your little binary file available for you. And here we can actually see the JavaScript where we're making use of it in the page. So this is just your standard client-side JavaScript where you've included the WASM in. You can see we're making that encode call there. We're getting the result pointer. We're basically spitting the result out into a blob. And then here you can see that now we're taking that result and we're putting it into a blob, which we're specifying as WebP, and then we're just attaching it to an image source element, resulting in something beautiful like this. And if you go along to here as well, you can actually take a look through the resources that are being loaded. Now, in this particular example, the WASM file that results is fairly chunky because Surma has actually put a whole bunch of other things into it. But if you compile it down to just the things that you need, you can actually get a pretty lightweight binary that comes out of it. And the point of this is that suddenly you sort of have these client-side microservices that you can run reliably in any environment. So with things like this, you're not dependent on the browser's underlying implementation, which may differ from platform to platform, but you have a guaranteed environment in which to run a particular piece of code. Okay. Next bit then, we look up, and this time, it's an Android app. Now, I just wanted to in fact, who's done Android development as well? Okay, good, because I was Sometimes I put stuff in that I think is really advanced and everyone's like, no, this is old news to us. Or sometimes I put things in that I think are really basic and people look at me with this confused face. If you look at me with a confused face, I will slow down. No, I won't. We're running out of time. I'll just go fast anyway. So, deep links first. On the Android side, a deep link means that if I have the app installed and the app has said it is able to handle certain URLs, then Android can optionally push you to the app rather than the URL. I kind of like this because this is actually just kind of like saying my app is a specialized browser for this type of URL. And this, unsurprisingly, inside of Android is handled with a bunch of XML. You don't really need to understand what's going on here again, just to kind of point out that in the manifest for the app, this is where you're defining the URLs that you're capable of handling. And they don't need to be URLs that you own as well. CityMapper does this interesting thing where they can actually intercept Google Maps URLs. So if someone sends me a Maps link, I can actually open it in CityMapper to get directions there. Okay, that's not super interesting. What gets a bit more interesting is if we talk about app links. So app links are kind of the same thing. It's a deep link. But instead what you've done is you've actually verified that you own that domain and that that app is associated with this domain. So this goes in the assets links file, the JSON file that sits on your website. If you have an app and you haven't done something like this already, I would strongly recommend looking at it because there's also a little smart lock thing that I'm more than happy to waffle on about later, but is well worth your time. So in this instance, we've now said that this app and this site are definitely associated with each other. And I just wanted to jump back to my definition then of a URL, where it's kind of like, oh, it's a human readable identifier to allow the loading of data and code needed for that resource. And as web developers, we're generally used to the sort of architectural structure of saying, oh, whenever this request comes in, I'm going to push back all of the resources needed to load that particular resource, page, app, whatever it is you've put on the end of the URL. Now, interestingly enough, we've started hearing this kind of thing from Android developers as well. So with Google Play Instant, the instant apps, what's happening here is when you hit a URL that has an app associated with it that is capable of being delivered as an instant app, then optionally Android will kick in and it will deliver just enough of the app to actually run for you. So an example here from Anna, who actually works for the Deliveroo Android team here in London. She had this app called Paper Football, which is a neat kind of little like pen and paper based thing where you're sort of following grid squares to try and play football. I am not a football person, so I sort of got that you want to get the blob in the other goal, but that's not the point of this talk. This, which you can actually go along to that URL there, and if you have instant apps enabled, then you should see some kind of instant app experience. I kind of wanted to share it with you here, but given that I'm actually a Google person, that means my phone is never really working properly, so I couldn't get this to load. But I'm assured it's a lovely experience. And what tends to happen is once you're inside of there, you're using this partial bit of the app. And one of the patterns that I'm intrigued to see how this plays out is from there, you can actually upgrade to the full app experience. So one of the business problems that people ran into of trying to get app conversions is actually a bit delayed now, and the installation is actually going on in the background. But that's kind of like, that's a place where Android is playing catch up with the web, because we can already do that. So what's a place where we're looking at things that Android is doing? When you go beyond just having this ephemeral app and you actually want to repeatedly use something, you're going to add it to your home screen. Android recently introduced this thing called app shortcuts. And what that means is on newer versions of Android, if you long press on your app, you might actually get a few of these additional shortcuts out of there. And on this side, these can either be, unsurprisingly, configured through more XML. But these are the static versions, so these aren't that interesting. That might be, if it's a Facebook app, maybe it's like my profile, my friend's feed, a bunch of standard top-level headings. What's more interesting is that you can actually add these dynamically. So for example, if you have WhatsApp on your phone and you long press on that, you should see app shortcuts for your most contacted people. Now, again, this is one of those areas where it's kind of like, well, the web can do this because we have URLs and you can bookmark a URL. But what we're missing at the moment is a UI that provides that more kind of intelligent bookmark manager, like the site actually suggesting to you what should the top level add to home screen things be. I think there's a way of playing with this, that you can take a look at. And I want to double check how speedy I have to be. Oh. Okay. Who has played with Add to Home Screen before? Yeah? Who has like apps regularly added to their home screen that they use on like a daily basis? Okay, cool. Right, so the thing about Add to Home Screen though is it's Chrome without the Chrome. Oh my God, okay. But the point that I'm trying to make here is that by just doing Add to Home Screen, you can actually create a bad experience for your user. Because if you haven't put the consideration in for what happens once you take away all of that browser navigation, you may be doing something wrong. And even though Add to Home Screen is very easy to implement, it's harder to create a good experience with it. And if you just do that for your top-level site, this may leave like a poor taste in your mouth afterwards for trying to do any of these features in the future. So what I want you to try and think about is creating these discrete, non-invasive, and measurable use cases that you can use on an incremental way to see if something like Add to Home Screen is going to work for you. So in this case, I want you to consider something like if I'm trying to order a sofa, I probably don't want to add the top page of your site back to my home screen because I'm not someone who buys sofas on a daily basis. But when I've ordered the perfect sofa from you, it's going to take a couple weeks for you to construct it. So I probably am going to want to come back to track that order. So what I would like to do is add that order to my home screen and keep an eye on that. And so the way you do this is the manifest that you're exposing is just a resource on your server like any other. That means you can respond with dynamic content there. So in this instance, I've just done something where I'm under order/12345, and I've got a manifest under that. In this case, it's kind of a static file for that order, but the point is I've sectioned it off. And when I talked about measurement before as well, you want to look for these event listeners, because as well, with something like this, you probably don't want the browser to automatically prompt me to just add something to my home screen if I'm in the middle of a conversion flow. Instead, you want to allow me to do that based on a user action. And inside of here is where you're listening for that prompt and responding to it if you've put some kind of element on the screen to say, add to home screen. And I was playing around. I'm not very good at hashtags, so this is an unfeasibly long one. But my feeling here is that this goes beyond just adding the main site to your home screen, but you start building these kind of single serving sites where it's just, I have my sofa, and that's going to exist on my home screen for the lifetime of that order. Okay, and where can you measure that? So I just wanted to point out, I showed you the deferred prompt that I'd captured before when the user actually clicks on, yes, I want to add to home screen. And inside of here, you can actually get the user choice. So you can see if they dismissed the prompt or if they chose to install it. And here, I'm just using Google Analytics, but obviously whatever analytics provider or method you want to use for tracking, did they install it, did they not? You pop it in here. Then, on the other side, inside of your manifest, you'll also probably want to add some kind of tracking on the start URL as well, because you want to understand how many times people are launching that app from their home screen. So you can see here, again, unsurprisingly, I've just used Google Analytics here, but you can pop whatever get parameters you want on the end, because again, it's just a URL. Oh, yes, good thing I highlighted that, because that is important. One of the things about this is you want to ensure that these single serving sites are non-invasive. That means you use the scope parameter to say, I only want the add to home screen experience to kick in if I'm under this particular section of the site. That means you can put the UI and UX work into making sure that that subsection of your site behaves well without any Chrome around it. And then when the user leaves that, they actually just jump back into the browser to browse the rest of your site as a website. Okay, next up then, when the user is actually inside of the app, if they're using it in add to home screen mode, you can actually make use of the display mode media query here to see if they are in standalone mode. So this starts to give you an understanding of, are people using it in the browser or are they using it in the add to home screen experience? Now, onto the kind of final role of this. Who loves notifications on the web? One person. Thanks. I will give you your £5 later. Now, I think this is not a problem inherent in the technology. I think it's good that we're making the web a more capable platform. However, it means that we've given people a lot of power, and they've gone out and started shooting themselves in the foot and started shooting other people in the feet, and that's not really a look that we're after. So I want to use this Venn diagram to show you what I think encompasses a good notification. If you are sending a notification from your website, it should be personal and relevant. That notification should be meaningful for me, not meaningful for someone else. If a sale is starting, that's not a reason to send a notification. But if a watched item that I care about has just come into stock, that is a reason to send a notification. And it should be precise and complete as well, right? The best notifications are the ones that I don't actually need to tap, because they tell me everything that I need in that snippet there. And finally, it should be timely. You can set an expiry on notifications. So if it is something like a flash sale or it's my taxi arriving, once that time has passed, you can expire that notification, and it's not there taking up my notification shade, adding enough things across the top that it looks like I just have a solid bar there. Do all of that, and I feel like we could create notifications that people love, rather than notifications that mean people just disable it for the platform as a whole. And I felt it looked something like this. So if I'm tracking my sofa, I've got something that's personal to me. You can't deliver that same sofa to multiple locations, or if you do, I'm going to be unhappy. It's timely because it's telling me that it's going to be here in 5 minutes, and it's complete as well, because if I'm all ready, I don't have to do anything with this notification, but I can take some helpful actions. And going back to our little property here, what does that look like? This is the data that gets pushed in the push message to your service worker. So you can see that I've got the action in there, I've got some targets, and basically in here, when you receive that push notification, you are showing the notification. That's where you would add the analytics if you want to know that the notification has been displayed. And then the matching part of that is you're also listening for interactions with the notification. And inside of here, you can see I'm pulling out the action, and I'm opening a window in response to that. You don't have to open the window, you can do something else if you want. Okay, and finally then, on notifications, ask for permission in context, right? Do not, as in fact, when I was looking for a news site to look up something about notifications, I landed, and the first thing it did was ask me if it could send me push notifications, which obviously got the block response. Do it in context so that I know what's going on, because you're not spammers. No? Good. I view you as kind of stewards and pioneers in the ecosystem. So what I want is you to go out there and create these good, meaningful experiences with notifications so that we can try and roll back some of the damage and perception that we've got there already. Okay. How are we doing? Nice. Notifications aren't needed in every single example, though. We can also do some slightly less invasive things. If you have a recent version of Chrome, this is the Twitter PWA, where I have some notifications, and you can see that it's actually badged slightly to indicate that there are some active notifications. I needed a screenshot in a hurry, so shout out to James, because the first thing I did was just tweet, test tweet, don't interact. 35 seconds later, he had interacted with it. So thank you, James, for just being contrary in your nature. Now, what we've actually got coming is Miguel has proposed this badging API. So you can go along to the GitHub repo and take a look there. Also, if you're just generally interested in getting involved in standards development, this is kind of a good place to do it, because this is very early on and it's quite a simple API, and the people responding are quite friendly. So if you have opinions or thoughts or just want to see the process in action, this is a good place to do it. But you can see what he's suggesting is adding a badge object, which would be available on Windows and workers, and it just has a set and a clear method where you can set something like this. Let's assume this is a messaging application. We've got our unread messages, we're setting it in the badge, and that will appear as a little number on our badge. And you're not just limited to numbers. You can also put emoji in there. So the other thing you could do is, let's say it's a flight tracking app and your flight is now ready for boarding. You could add a boarding badge there. Or let's say that you have some kind of image sharing app, and people are sharing lots of images of pictures of their children, which you're not super interested in, but you are interested if they start sharing pictures of cats. So you have a little badge that tells you when there's a new cat picture available. Okay, that's early days. That's not ready yet. It's just out there to sort of play with and look at. So what should you build right now? What am I going to suggest? Given this audience, I might suggest that we should just all be building websites, which we should, but how are we going to build those websites? I'm not going to answer this question. I'm just going to give you more possibilities and send you away more confused. So to wrap up, I wanted to take a look at this. In the Android world, they have been sort of switching from Java to Kotlin, and Kotlin is basically like Java, but imagine you just took out all of the unnecessary boilerplate and had like a slimline language instead. So Wojtek has this repo here, where he's written a little Sudoku solver for Android. It also runs as an instant app, so it just displays the board, and then you've got a solve button, and you can go from there. However, what's interesting is that he also has this hosted on the web. And if you go take a look at what's being downloaded here, this is a little bit heavy because it's downloading the Kotlin JS runtime, because you can cross-compile or transpile your Kotlin code to JavaScript. And what he's done is actually built out so all of this is shared Kotlin code, the same Sudoku engine, the random number generator. This is all exactly the same Kotlin code that is running the Android app as well. The only bit that he had to do that was specific was writing a little renderer plugin where it's actually pulling in the DOM elements to do the rendering. So if you include, this is the Kotlin code that's doing it, what you can see is that in Kotlin you actually have access to like the canvas rendering context, the HTML canvas element, and you can just use those. And if you look down here, it's like this starts to look suspiciously like JavaScript. So you can just compile that out, and you can have that same code base that is powering both your Android app and your web app. Whew. Okay, so that's what I want. I want you to go out of here feeling like you're thinking a bit more about how are you going to create apps and sites that are going to get people to connect to the thing they want to do, rather than it just being a way of using every single new technology that's available to you at the moment. Slides are available over here. I'm available on Twitter here, and I will be around for questions and trivia and anything else later on. Thank you.
Hello. Thank you, Rowan. As Rowan said, he's from Google. 10 years ago, it's almost to the week, a new browser came out, and that was Google Chrome. And I bet most people in this room now have that set as maybe their default browser. Maybe they've only just changed it this morning to Brave, but 10 years ago, 69% of users in the world were using IE, and that has changed drastically, and that's only a very, very short time. I'm just going to wait for Ada to come and plug in her stuff, and Ada represents yet another new browser that's dominating the world, certainly on Android devices, especially if they've come from Korea. Yeah, so Ada's going to tell us about some really cool stuff that we can do with augmented reality, extended reality, virtual reality, and cool. So I'm going to hand over to Ada. Thank you very much.
Health and safety. There we go. We're going to fly into the audience. Cool. So hi, I'm Ada Rose Cannon. I'm from the Samsung Internet Browser, and I'm here to talk to you today about XR in the web. And I'll get into details on that, what that is in a sec. So before we begin, move my mouse on the screen. So who here's heard of our browser before? Holy shit! Okay, good job. Who here uses our browser? Yeah. Okay, we're really cool. We're like, we're an Android browser. If you have an Android device, you can download it and use it. We're just released the latest beta version of our browser at the moment, which is like some really cool stuff like JavaScript imports and web components and web Bluetooth, web payments. We're really focused on like driving forward some new APIs in the web. So we're heavily involved in the Immersive web community group, and we're like in web payments and another API which I've forgotten about, and I'll definitely remember halfway through my talk and kick myself. So one last question: who here tests on our browser? So a few of you, right? We have like 7% market share in the UK for mobile devices, which may not sound huge, but considering there are millions of people in the UK, like it ends up being quite a large amount of users. So like, if nothing else, please download Samsung Internet on your testing devices just to make sure that your sites work across. Because although we're a Chromium fork, there may be some slight differences between us and Chromium. Cool, so there is one more awesome thing about our browser. It works in virtual reality as well. So this is Samsung Internet for the Gear VR, which is a full-featured web browser running in a virtual reality headset. And I like this particular example because this is running the Space Jam website. Who here is a fan of the Space Jam website? Yeah! It's like my favorite website ever. I'm actually not joking, it is actually in my bookmarks. Like, there we go, where's Space Jam? Space Jam, Space Jam, Space Jam. Because who doesn't love the Space Jam website? Anyway, so this website was developed in the mid-90s, and it was built when the very concept of this device was unimaginable. So it's running on a handset more powerful than any computer of the time. It's running in a web browser, in a device which was pure science fiction, in a virtual reality headset, which is just super cool. And here it is working just like normal. I definitely just disconnected my controller. There we go. All right, so here's what I'm talking about today. XR in the web. So has anyone heard of the term XR before? A few of you, okay. So if I just disconnected this somehow, so I'm just gonna refresh the page because that always fixes all errors. Come on, work. Oh, my controller's broken. Oh, no, there we go. Just my computer's being really slow. Cool. So yeah, XR in the web. So XR is an umbrella term for VR and AR together. So, and the reason for this is that they're not, augmented reality and virtual reality are not two distinct technologies. They're two ends of the same spectrum. So virtual reality is where you put on a headset and you replace the entire environment around you with a virtual scene. Augmented reality is where you either use a phone or a headset and you'll be adding virtual objects into the world around you. But there's a gradient between them. So you can replace more or less parts of the scene or the environment, depending on what you're on. So if you're on an advanced headset, like the Microsoft HoloLens or the Magic Leap, then you could probably replace like the floor and the walls with entirely virtual content but still have it considered like augmented reality. And the middle point's often called mixed reality, or MR for short. So to uncover all these terms, we've just called it XR. So to recap, so virtual reality is where you are surrounded by the virtual environment. And AR is when you're bringing virtual stuff to you. So XR is the umbrella term for mixing reality and generated images. So why XR on the web? And this is kind of an interesting thing, because traditionally, the web has been a 2D medium. But I really think that XR devices, so headsets designed for bringing information to the world around you, are going to be the future of our hardware devices. And the web had a bit of a rough transition from desktop to mobile. As you probably all remember, the hellish time we had building web pages for mobile at first, if you would have building web pages in those days. And so the web, so when these devices start becoming standard and used more regularly, I'm not talking next month or in 1 or 2 years, but in 5 or 10 years, the web's going to need to have a presence there. But the web can also do a lot for XR as well. Because right now, the state of XR is one where if you want to use any kind of XR interaction, it usually involves downloading an app, which is hundreds of megabytes to several gigabytes in size. It takes a long time to download. You then have to fire it up and use it. And then once you've finished with it, even if you only use it for 30 seconds or a few minutes, you then have it laying around on your device just taking up space. And this is the same problems which we're trying to solve with native apps and progressive web apps. And it's just a more extreme version of this situation. So if you just want to build something that's really accessible to devices and connect to users, but for virtual reality, the web should ideally be the platform for you. So by having VR capability, XR capabilities in the web, not only are we bringing the powers of XR to the web itself, but we're bringing the powers of the web to XR, which is amazing. Has anyone here built any XR stuff, VR or AR or anything? Oh, a few of you. Have any of you used any VR headsets or AR headsets? Cool, a lot more of you. So I'm glad to see you're trying out some of this content. Actually, have you tried any web VR stuff yet? A few hands. Yeah, because VR works on the web today. You can load up a web page on pretty much any VR headset you can get your hands on. I think aside from PlayStation VR, which for reasons, doesn't have a web VR capable browser because there isn't one on the PlayStation, but for Windows or Mac computers, Chrome and Firefox should be able to, and on Android, and even on iOS with the Google Cardboard, you can access and display content through the web with virtual reality, which is really cool. It's really powerful. And yeah, the WebVR APIs work in our browser too. We've had them for a long time. This is actually a demo from last year sometime. So what I've done here is that I've landed on this web page, and it just looks like a normal web page where I'm displaying some content. I press the immersive button, that looks like a little headset, which is a button I've added to the screen, which tells the browser this content is is prepared to use the WebVR APIs to display content immersively. And when I press it, it displays it to me through the headset, and I can look around and I'm in the scene, which is really, really nice pattern. The BBC has made a really cool project, I think like late last year, which works in WebVR, this is a really cool case study of building a WebVR experience designed to work across many devices, from mobile devices on through Google Cardboard and the Gear VR and Daydream, and also for desktop headsets like the HTC Vive and the Oculus Rift. The Amazon Sumerium project is a great web-based project for building VR experiences for the web. It's really powerful, and Amazon actually joined the W3C to help work on the WebVR APIs, which is super cool and amazing, and it's great to see big companies like that involved. So here's how the WebVR APIs work. I'm not going to give you code samples because the API is still changing, it's still being cooked. And also, you'll probably never use it. I'll explain why in a sec. So here's just a rough idea, so you know what's happening when you do build something which involves it. So your headset will have some capability of working out its position and rotation in your environment. This allows you to, when you look around in real life, to map the virtual content to your head position. You render the scene, the virtual scene around the user from this head position. You can work out the position of any controllers they're having, such as, okay, this is a Wiimote, not a VR controller, but any controllers they're having, and you can draw it in the scene where the controller would be. So they can look down and see the controller and it lines up, so they can still push the buttons. You can then render that scene with WebGL and send it to the headset and be like, look, I've rendered it to the positions you've told me, please render this. The WebGL APIs will then do some smart stuff to make sure that it gets distorted correctly for the lenses in the headset, and that it gets tracked as they move their head, even if you're not hitting the frame rates correctly, just to give the user a nicer experience. So this is the kind of effect you end up with. So they can use their controllers and look around and interact with the virtual world. Because after all, this interactivity is what we're going to be after, not just displaying static content. So as you saw in my loop, you have to use WebGL to display content to the browser. So has anyone here built anything with WebGL before? A few hands. So WebGL can be a little tricky. It takes a lot of work to get something even quite simple. So here's a short code example of how to render a cube. So yeah, you start off by getting the canvas and saying it's WebGL, and then you just type out some stuff. And boom, you have a cube. Was that too fast? Yeah, WebGL is really tricky. I can't do WebGL. I'm historically a graphics developer, and even I don't write WebGL. I use one of the amazing abstractions. So there's I've listed a few up here. So there's Play Canvas, which is a really nice WebGL library. And there's React, and there's Babylon.js, which is being developed by Microsoft and is also really good. My personal favorite is 3.js. It's kind of the oldest one. It's been around for a very long time, but it's still very actively worked on, and it's really good. And then there's A-frame, and which is A-frame is a web component wrapper for 3JS. So, have you heard of web components before? A few hands. Right, web components allow you to write JavaScript which defines your own custom HTML elements. So by being a web component wrapper for 3JS, it means you write HTML and you get VR-capable 3D scenes, which is just amazing. So that demo I had at like my second slide where I had the Samsung Internet logo rotating, that was like 7 lines of HTML with the A-frame library. So if you're a web developer and comfortable with HTML, but WebGL looks a bit gnarly, like A-frame is my go-to. If you're like a frameworky, React-y kind of person, I'm not super, but I know there are a few out there. React VR is a React wrapper for 3JS. It was written by Facebook and is another great way to get started for if you're more comfortable with React than HTML and web stuff. But WebGL has its downsides. So there's no DOM access. You can technically render DOM in WebGL, but the way you do it is that you import your entire style sheets and everything else into an SVG. You then render all of your HTML inside a foreign element in the SVG, render that to a canvas, and take the bitmap data from that canvas and send it to WebGL. As you can imagine, that's not very performant, and it has the problem that because it's a bitmap, as you walk closer to the HTML element you've just rendered, it gets all pixelated. And if you walk really far back, it gets, usually the MIPS aren't so great because you haven't rendered it to a perfect 512 by 512 or whatever. You can do text in virtual reality or in WebGL, and there's some really cool, I think they're called signed depth maps or something. There's a 3JS library for it, and you can do text, but then you end up with this thing where half of your memory is taken up with all the bitmaps for your text, just when you include like a couple of font families, which isn't ideal. So when we're designing our scenes for the web, we start having to think about how can I send my message using 3D models, sounds, lighting, images. So it's a different way of thinking about making websites, which we're probably not used to, but is a really great thing to try out and solve problems in a different way than we're used to with the DOM and CSS. And probably the biggest downside of WebGL is that there's no built-in accessibility. So because there's no DOM, there's no accessibility tree. So if someone who needs visual assistance with the page tries to look around, all they're going to see is there's a canvas here. No other information. So if you want to start building WebGL scenes which are accessible, you have to manually write in the audio descriptions yourself and code some way for people to interact with your sites. And it's a bit trickier, but it is important we think about accessibility when building VR sites. After all, the web is for everyone. It's not just for those with great sight. But yeah, aside from that, WebGL is great. So I've been talking about virtual reality on the web so far, but WebVR is changing because these APIs were first developed for this device. which was the Oculus Development Kit 2, which is a cool device. It was amazing, and it changed the world when it came out. It kickstarted an entire industry. But things have moved on a bit since then. So augmented reality applications have been really popular. Has anyone here played Pokemon Go? Honestly? Yeah, like it took the world by storm, and is like an ideal application for the web, because it's simple augmented reality. There's also new XR capable headsets. So there's Microsoft HoloLens and their mixed reality platform, and the Magic Leap, both of which allow you to, they're both transparent headsets, so you can still see the world around you, and there'll be virtual content overlaid on the environment. And it's incredibly powerful and really cool. You can place a virtual object on a table and walk away and come back, and the virtual object will still be where you left it, which is incredible. And these are the headsets we need to build for the web for the future. What's on this slide? Oh yeah. So this is what WebVR was designed to cover, specifically virtual reality headsets. But this is the state of the immersive world as it exists today. So aside from our virtual reality headsets, we've also got the augmented reality headsets, which are really powerful. They're also really expensive. So has anyone here used a HoloLens or a Magic Leap? Yeah, so a few of you. I'd love to own one personally, but it's way out of my budget. So often people are doing augmented reality through handsets, much like Pokemon Go or any other AR application. And one thing we found when people were building the WebVR APIs is that they weren't insisting users use a headset, because you want to build something that falls back reliably for when people don't have a headset on them, or when they're in public and don't feel comfortable using a VR headset. So as well as being able to use it on a desktop with a keyboard and mouse, people were building experiences where you look at it through the mobile phone like this, and you can look around. And this is known as the magic window experience. And it became such a standard that it's something we want to be built into the foundations of WebXR, because it really enables progressive enhancement for the web. So you could build one WebGL experience, and with only minor changes, have it work on desktops, on mobile phone through Magic Window, and VR headsets. But as well as that, you can also build in functionality so that they can use AR to place pieces of the scene around in the environment around them. So you can place something on the floor or on the walls and interact with it that way. So these APIs are imaginarily called the WebXR device APIs. And this is an example of the AR functionality. So you can do this today in Chrome Canary with the prototypes of the APIs. So here they've looked at an article which has a WebGL rendered astronaut in it, and they press a button and it lets them use WebXR to place the astronaut into the environment around them, and they can see it to scale and look around it. We're also looking at changing how the controllers work. So previously, the way that you'd get the position and the rotation of gamepad API, of the controllers in people's hands, was that we added extensions to the gamepad API, which, as well as telling you what buttons were pressed and the location of any joysticks, it would also have the position and rotation of the controller, which is really great in terms of you can build for in-depth on any particular piece of hardware. But what it means is that in 3 or 4 years down the line, when no one's using that hardware anymore, your scene would stop working. So we've tried to extract the information from the controller into an XR input API, which gives you the position and the rotation and gives you events for pushing one button on the controller. So it's a much higher level overview, much higher level API. But the nice thing about it is because it's part of the platform, it actually counts as user activation events. So you can use it to start videos playing and request permissions, which you couldn't do with the gamepad previously. And because it's a generic interface, if you built a XR-based experience using the XR input API, it would work on a 3 degrees of freedom controller, like a Daydream or a Gear VR. It would work on a 6 degrees of freedom controller, even ones which haven't been built yet. And it would even be possible for browsers doing hand detection to allow you to draw a hand in the scene because it knows where the hand is. And it could probably even interact to like, if you wanted to click on something using finger guns, you could do something like that. So that's why I use a strap. And the nice thing about this is that you can build a website which will last into the future. Because like the Space Jam website, we want to build experiences which work again and again and again and are not tied to specific pieces of hardware. Oh yeah, and you can use this today. So, like, as I said, the API is still changing. But you can use it in Chrome Canary by turning on a few flags. And you can use the XR polyfill to polyfill it on devices which don't yet have the XR device API enabled. If the WebVR APIs are available, it will even use them in the polyfill to make it more performant. So you can get some, so you can start trying it out. We're also trying to change from a community group into a W3C working group. Who here works for a company that's part of the W3C? A few of you. Who here knows who their AC rep is, their advisory committee rep? Cool. If you don't, please find out who your advisory committee rep is and ask for them to vote for us. That's the cool thing about being on stage, I can do that. Yeah, because we really want to start a working group, and it will allow us to finalize these APIs and get them out into more browsers and into the W3C standards. Thank you so much for listening. You've been amazing. Follow our team at samsunginter.net. And we're on Twitter at SamsungInternet. And if you want to get involved, the community group and working group are really friendly, really nice. You come talk to me afterwards if you want to get involved, because yeah, I'm trying to get this thing going well. Cool. Bye.
Thank you very much. So yesterday, Samsung Internet did tweet that they're hiring. They're looking for another developer advocate. Is that right?
Yeah.
So if you're interested in that, look at the man with his hands up right at the back. Talk to him. or talk to Ada, and she will point you at Dan, and we'll sort that out. So, that's it for this morning, or this morning and a little bit of the afternoon. I know how time works. We're going to kick off again at 2 o'clock. Thanks for that advice, Andy. So go find some lunch, go find some food, and we'll see you back here at 2 o'clock for another round of awesome talks. Hold that. That's better. Good afternoon, everybody. We're just pulling those last 2 or 3 people into the room, and then the doors are going to shut behind you, and we're going to seal you in. I know you've just eaten. I know you're a little bit tired because you probably had pie and mash and peas and all of that, the best food in the world, and you're a little bit tired. So we're going to wake you up. About 4 years ago, we put on State of the Browser, and we got a talk submission from a young lady stood next to me. And she came, and the talk that she gave that day blew me away. And Chris is agreeing with me. It was fabulous. And ever since that day, I wanted to come back and speak at London Web Standards or State of the Browser. And I'm absolutely delighted to say that Ruth's here. And I'm going to hand over to Ruth. So, off you go.
Come on, man. But tonight, don't call it a comeback. I've been here for years. I'm rocking my pants, putting suckers in fear, making the tears rain down like a monsoon. Listen to the bass go boom, explosions.
Oh, I love a good hip hop opening. But the sound guys are always like, so quiet. And I'm like, come on. Stay at the browser. And how was your lunch? Are we awake now? Yes. Okay. That's what I wanted. And I'm having technical difficulties, which I knew I was going to. And my speaker notes are not working. So should we take a vote? Shall I do it with or without the notes? Without. We're just going to carry on. Oh my God. I've never done this talk before. Oh, this is going to be super fun. I think I'm going to need the notes. I wonder if I can just do that. And it'll... No. Do you know what you shouldn't use to do stuff like this? JavaScript. Yeah, I know. There we go. To be honest, I'm going to have to do this anyway. So, let's do that and come here. Yes, thank you. I bet it still doesn't work. It's still not working. Best opening ever. I know. Yeah. Yeah, use Firefox. Absolutely. There we go. To be honest, we need the browser, so let's do this. Super profesh. Okay. Okay, cool. Now we're working. Browsers are cool, right? Okay, thank you. Thank you for bearing with. I'm glad Dave mentioned this actually, because yeah, it is quite prominent. I'm pretty sure the last time I was here, I was doing some crazy visualizations and mixing them with gamepads and doing this kind of crazy stuff which browsers shouldn't do. And to be honest, nothing has changed. I'm going to be doing some of that. But in reality, things have changed. In fact, everything has changed. In seriousness, for the past few years, I have actually been creating a lot of these visualizations to the point at which I do now take a piece of software 2 gigs and do this on stage, which is a little bit silly because the software is made in JavaScript and doesn't always work, which I'll get to in a minute. But it has turned into a bit of a thing, actually. And so what I will do, in case anybody's missed my life, no one follows me, right? I'll do a little bit of a rundown, all right? Okay, so missed it? Cool. It's all right, the GIF's not working. I know things. It's basically what Chris is saying here. I know things. Here's a quick rundown of making audio visualizations in a browser, because that's not what this talk is about. This is part 2. This is doing this stuff and then making it work, all right? If you need to know more, that is my previous talk, and it is out there, and you can find out about it. First thing you need for audio visualizations is you need sound. You need some audio. You can do this with the Web Audio API. There's 4 main ways to do sound with the Web Audio API. The one I'm using here is I'm using my mic. So I'm using the Media Stream API. I'm grabbing my mic and I'm streaming that into the Web Audio API. That's super cool. The other thing that we need to do once we have that sound is we need to analyze that sound. Also done with the Web Audio API. It has an analyzer node. So we can grab that sound and we can analyze it. This is going to return to us an array of frequencies from high to low and the gain value of those frequencies. What? Yes, I know. I haven't even started yet. It looks a little bit something like this, right? So our low sounds to our high sounds and the volume value of those sounds at any given time. Okay, now this is important because this is the data that we are going to use to make our visualizations. And we can do anything that we want with this data. That's the whole point. So we can animate DOM elements, we can get some SVGs involved, like we can just take these numbers and we can just do cool animations and visualizations with them, which is the whole crux of what I've been doing and the whole crux of what I actually do on stage. See, it looks really cool. Everybody here is doing JavaScript on stage, by the way. Oh dear. So one thing that I did do recently, sort of in the past sort of year or so, was I moved all the visualization stuff over to Canvas. Right? And I was using a 2D context on Canvas. So I was doing stuff like in the DOM, and I was using SVGs and all the rest of it. But for performance reasons, I moved it all over to Canvas because it was cleaner and it was faster and I could deal with the processing better, or so I thought. I was playing a gig last November in Budapest, and the software crashed live on stage. VJ top tip, make your desktop an image that you don't mind seeing on stage, right? It's top tip number 1. And I thought, I've just put all this really, really hard work into making everything really performant, and it's not worked. So, this isn't a talk about how to be a web AV artist. Sorry. One weird trick to being a web AV artist, or as I like to call it, web workers and worklets. Yeah, the best subject for after lunch on a Saturday when you're all falling asleep. Hello, my name is Ruth. I do things with browsers that you shouldn't really do with browsers. And then the browsers enable me to do it better, which I've always found really, really odd. I'm always like, oh yeah, I did this crazy thing in a browser. And then they create an API for me to actually do it. I'm like, well, no, you shouldn't be able to do this stuff. It's just super fun. I do the codes. That's what I do. I also laser cut code keyrings. I don't have a proper job. Please buy my keyrings. They're on my Etsy store, made by Viera. These keyring monies get turned into food for my face. So please buy them. I have a discount code for you, SOTB18. So if you go to my Etsy store and buy a keyring, I get to eat food. Thank you very much. I have some samples with me if you'd like to try before you buy. These JavaScript ones are definitely the most popular, and there's only a couple of them left, so get in quick. 20% discount. Shameless plug, I know, but you've got to make money somehow. Web workers. Let's talk about web workers. Let's talk for a minute about how the browser processes code, or JavaScript code, right? JavaScript is single-threaded. So what tends to happen if you're just working within the browser, in the main thread, is you have to wait for one thing to happen before anything else can happen. So you have to wait for little lemming to dig through before any of the other lemmings can get to little lemming town, right? This is a game called Lemmings, if you hadn't figured that already. Legitimately, this is a game called Lemmings. This is a screenshot from that game, which is a cultural reference that not everybody's going to get. So the idea behind workers is you actually spin up other files with code in that don't happen on the main thread. So you can actually run code simultaneously. So instead of having one little lemming, digging through, you can have lots of little lemmings all digging, all by themselves. So everybody can get to the little home quicker, which is great. A little overview of some information about workers. You do run them in a separate file. So you've got your main JavaScript file, and then you have workers in separate files. You instantiate them with the worker constructor. It is run in another global context, so I'll get to what that means in a second. And I do have a lot of demos, so I've got some code to show you. This is your first bit of code just to warm you up. So in your main thread, you create your worker and you reference the file, right? There is no, because you're in a separate thread and you're in a separate context, there is no availability to objects like the window or the document or parent. They're not available. And in fact, there's no DOM either. So really what you're doing with workers is you're trying to take the sort of more codey processing code out of your main thread to free it up for all your DOM and all the other stuff that you want to do. There is some cache. There's some HTTP request. There's normal JavaScript functions that you might find, things like mather there, set timeout, things like that. Not all of them. There is, you can import scripts and you can create other workers, which we'll talk about a little bit more in a minute. There is a whole list of what you can and can't do on MDN docs, because that is a great resource and you should use it. A little note, there are dedicated workers and there are shared workers. So you have your main script, and you have a worker. A dedicated worker can only talk to your main script. A shared worker can talk to lots of different scripts and can talk to each other. For the most part, when I'm talking about dedicated workers because there are slight differences, but when you're working, you probably will be working with both. I wanted to put this in just for this lemming GIF. You can terminate workers and you can get errors from your workers. That is all possible. To get errors, you kind of have feed the errors back into your main script, and to kill a worker, you just use the terminate method. Cool, okay. I thought it was going to take longer, and it's kind of really boring, and everybody's like, what's Ruth doing? This is a super boring talk. I'm like, I know, sorry. It will become more relevant in a minute. So this is an example, and I can show you it in files in a sec. This is our main thread. We're creating our worker, and we're sending it a message. And then in our worker, we're listening for that message, and then we're sending a message back to our main JavaScript file, where we're listening for that message. And that's basically just how you pass data back and forth. Let's take a look at a simple demo. Now, if I remember correctly, am I even over half? Simple demo? Yes. So I've got an HTML file. They're pretty important things. Everybody should do that. I've got a CSS file to make it look good. Also pretty important things. But I've got my main JavaScript file over here. Main JavaScript file over here. And then I've got a worker file. So in my main JavaScript file, I'm creating this worker. I'm saying, hello, can I have a worker, please? And then I'm passing it a message. And then in my worker, I'm listening for that message. I'm doing some maths in this worker, and I'm sending it back to my main JavaScript file. So my main JavaScript file doesn't have to do this maths. Now, the maths that I'm doing is the hardest maths. I'm asking it to do my 13 times table, because obviously that's why we stopped at 12 times table. You know, when you're coding, you're like, oh my God, what is 13 times 8? Now you can just use this, right? So all we're doing is we press the button, and it will just return us 13 times table. And actually, that is super lightning fast. I'm like, whoa, whew, 13 times table. That's a really, really simple example. I will link to all these demos at the end for you, so you can look through the code. The data that we're sending to and from these workers is important. For the most part, if you've got data in your main thread and you're sending it to a worker, you're copying it across. Copying it across. So copies are being made of that data. And when you send it back, it's getting copied, and you're sort of like, okay, that's fine for the most part, but in certain circumstances, that's not going to work. In certain circumstances, I want the data that I've got in the main thread to be passed to the worker and then to be passed back. This is what we call a transferable. Also great, but bear in mind, if you do use a transferable, I'll show you how in a sec, your data disappears from the main thread. So you have to be aware that you don't need it in the main thread whilst it's gone to the worker and it's being dealt with and it's being set back, which can cause problems, and it has caused me problems. Another way to deal with this is with a shared array buffer. I'll talk about that in just a sec. Let's take a look at how you do a transferable. So when you're doing data copied, you just send the data over to the worker. It's really, really simple. To transfer it, when you post the message, you send the data, and in a little array next to it, you just say, I'm sending you this data. So that makes it a transferable. It's really easy. But bear in mind with this one, the data has now gone from the main thread.
Shared array buffer, this is when you've got your data shared between pretty much everything, which sounds great, apart from it had all these problems when Spectre came out, like the security flaw. So it got pulled from everything that was using it, mostly Chrome. Chrome pulled shared array buffer. It does sit behind a flag now, so you can work with it, but they have been dealing with getting it back into the browser and making it available, because this really solves a lot of problems when you're dealing with data in real time, which is what I've been doing. This is all really important to what I was doing in my software, because I was doing a lot of maths. I was taking the audio, I was analyzing the audio, I was reanalyzing the audio, which I'll talk about in a sec, and I was chucking a million shapes at the canvas and animating those shapes. Right? So a lot of stuff is going on. And Chrome's like, okay, cool, but it's just too much. And I'm a terrible coder as well. So it was just like, it just couldn't cope with any of it. The next slide was to demonstrate why I reanalyzed the audio. So I pulled out the worker from the demo. Doesn't work. It just doesn't, that's it. That's all you got. Doesn't work. So the workers that I have actually put into these audio visualizations are really, really helping things move along. What I was trying to illustrate is when you analyze audio with the Web Audio API, you're getting back frequencies from like 0 to 20,000 hertz, which is fine. That's what the ear hears, depending on your age. But it's like that's really, really high sound. And a lot of music does not go that high. You're looking at 10,000 tops. So there's a lot of data that we're getting back from that audio that we just don't need and doesn't make great visualizations. If this was actually working, you'd see most of the hexagons at the top left are moving, whereas none of the others are, because our voices, the sound that we run, just doesn't give us data in the rest of the array. So what I tend to do is I take this data, I do some maths on the data, and then I push it back to my visualizations to give us better visualizations. That's what we're trying to do. So putting this into a worker was a really, really, it really helped me out. If we look at the, I'm going to do an Ada, similar setup, index, CSS, got my main.js over here, doing some analyzing. In the worker, I'm taking that data and I'm doing some very, very simple maths on it. This is all commented out. Just really, really simple algorithm that I just whipped up the other day. Yeah, took me about a year to write it, by the way. But as you can see down here, there's a lot more data going on in that array. I mean, we've still got a little bit of noughts up the top, but this is way more spread out than we'd get if we were just passing it back from the audio API. So that's cool, that's running way faster as well. So that's really, really helpful, and we can just see it. Okay, cool, I've changed the size now, but whatever, it's cool. This is cleaner, this is faster, this is not making Chrome go, oh snap, which is great. So workers, super cool. The other thing that I wanted to mention, yeah, I've got time, is I think workers are important because we have worklets. Now, I said this a few months ago, and I tweeted out worklets, and someone tweeted back and said, well, what are worklets? And I said, oh, they're like workers, but in a specific API, I suppose. So, we have audio worklets, we've got offline canvas, I'll talk about those. And this guy, Ian Kilpatrick, he's nice, he came back and he said, yup, that's right. Basically, worklets allow us to run something within a stage of the browser engine and make sure developers can access something that makes the world explode. And I'm like, wow, that's a pretty good explanation, thanks. Yeah, he writes the stuff that makes this happen, apparently. So he's going to know. It's great. One thing that heavily uses worklets, something that we've probably all heard about, is CSS Houdini. This isn't really a talk about CSS Houdini, but I'm going to go over it anyway, because, information's good. This spellbook here is a great resource, which means I don't have to tell you everything about it. I can just, let the website do it for me. As everybody says, when you talk about CSS Houdini, they're like, oh, it's this suite of cool, super-powering CSS. And you're like, yeah, but what is it, though? And you're like, okay, yeah. So we've seen a little bit of it already. So right at the bottom here, we've got all the different bits. We can start as something like custom properties. Michelle mentioned custom properties in her talk. We've probably all seen them, right? The CSS variables, you can access the values in JavaScript. That's one small part of what makes up some of the other specs. The Paint API, I'm going to talk about this now. This is the ability to draw whatever you want as a background image in CSS. That's pretty cool. Animation API. So this is the ability of putting a worklet in animation so you can take all that sort of processing of the animations off the main thread as well. Also cool. And layout's probably worth a mention as well. So it's the ability to be able to make whatever layout you want. Masonry is usually the one that people come up with. Like, you don't need a library for this. You can create whatever one you want. They're all kind of very separate things, but they have sort of blocked them all together because they're all CSS based. There is a link to this as well, if you need it. So, if we look at CSS Paint API, probably a good example. This is an example of a worklet running in spec. All the CSS Paint API is the ability to draw whatever background image you want. And you are using what is essentially the Canvas API to do this. It's not exactly the same, but it's pretty much the same. So if you can use Canvas, you can use this already. You're calling the paint function in CSS wherever you would use an image. Right? So image, border image, background image, wherever. You call the paint function, and then you pass in whatever you've called your little worklet thing, right? And then in our main script, we are registering our paint worklet. And this is much easier as another demo for 5. This is where it's too demo heavy. Okay. So, I love this. Both of my CSS Paint API demos have been breaking just over the past 2 days. I feel like I need to talk to somebody at Chrome about this. Yeah. So, it's not done that one before. Usually it just breaks. There should be a little circle in there. I'll talk you through the code anyway. In my little paint worklet, all I'm doing is I'm just using Canvas to draw a little circle, and then I'm registering that with my register paint function. And then in my CSS, I can call that paint function as my background image and call circle, which is just calling that JavaScript and just drawing a circle. Although, obviously, it's not working today. Probably be work tomorrow. Let's see. What I want to do is just see if the other one's working. Less simple demo. I bet this is all snap. Oh! Come on. Yes! Okay. So this is a less simple demo. Oh, it's so close, Chrome. Hey, this is the state of my browser. How's your browser doing? I did this in Canary and it was fine until it did that. And I was like, so it's just in everything. This one, if it did work, I could show you some very cool stuff you can do. Because we're working with JavaScript, you can actually pass in things like the width and the height of the screen that you're working in, and like the mouse pointer. So you can actually change the whole of this and actually update the image as you're doing it, which is actually quite powerful stuff. So the spiral itself does actually update when you change. These demos are actually really like low-key simple demos for me. Like I don't have any equipment up here. Don't demo on stage, everyone. So let's get this Paint API. That's cool. The other thing, the other work that you probably want to be aware of, web audio worklets. This is the demo that I think if you knew me, you'd be like, it's probably got a really cool web audio worklet demo because I code a lot of web audio stuff. This is as far as I got. Put some code here. This is literally the only demo I haven't got around to. You can play Chris, who's coming on next because I'm currently working with him and I'm doing way too many other demos with him. Web audio, for those that don't know, we're doing a lot of web audio, you're crunching a lot of data. And when the spec came out in 2012, straight away they realized that they needed something like workers. They needed to take all this crunching data off the main thread because of reasons such as timing and latency, which is really important with audio. And so they brought out a web audio workers spec, which has been around pretty much since the spec came out. But nobody did anything about it, because what happened was they started talking to the CSS Houdini lot, and they were like, oh, actually this worklet thing is pretty cool. So web audio worklets is pretty similar to something like the Paint worklet. You basically have the scope of the web audio API within a worker. And you can just like create one and do some really cool audio stuff in it, and it's all happening off the main thread. So all the sort of latency stuff that we've been dealing with for a while sort of gone away, and everybody in the web audio world is really excited about it. There are some better demos here. Like I said, there is a list of all of these links at the end, so you can see it. There is like a whole editor thing, so you can actually just play around with the code yourself if you are into audio, which is really nice. Off-screen canvas. This is actually probably why I haven't got around to audio worklet, because when it comes to my visualizations, this is probably more important. And actually, off-screen canvas you can do on the main thread, which I find quite interesting. This is code to draw onto the canvas, like kind of offline, as it were. It's kind of hard to describe. So you can do this in your main JavaScript file, and then just draw some stuff, have it not show on the canvas at all, and then just push it to the canvas. So this is what this is doing, but you have more complex examples of this where you actually do take it off the main thread and you put it in a separate file. So this is the best demo I've ever done in my life. Are you ready? So good. This one actually worked. It's a line. Yes, I know, I'm so excited by this one. But this isn't even a project, this is just a pen, because all the actual drawing is just happening in one main JavaScript file. And I'm just drawing that line sort of offline and then pushing it back to the canvas. I love that I know the order. This is a little bit more complicated. Thank you so much, Copen. I love you today. Come on. I just did a run through and it was just perfect. Come on, stay. So this would be something a little bit more like where I'm going to push it into the software if I could hook this up with audio and we could link everything together. This has got the separate worker canvas file, which is doing all the canvas drawing and then pushing it back to the main thread. So all of that is actually happening off main thread. This is great. Whew. They're my favorite APIs right now. It's all interesting, right? I kind of get really engrossed with the really sort of creative APIs and what we can do with that. But I think workers themselves are changing the way that we write JavaScript and are going to change the way that we write JavaScript if we are not using them already. Workers have been in spec since 2012, so I'm sort of like, am I really talking about something that's been around this long? But I do talk to a lot of people and they're like, what is this? Well, what are you talking about? We've all heard of something like service worker. Again, it's similar, it's working in the same way. I have just shown you the more like crazy ones. If you link this up with things like ES6 modules, WASM that we heard earlier, like all of that stuff starts to make JavaScript very, very serious, which is also kind of scary, but also it's like it needs to be the next stage. JavaScript's got very, very heavy over the past few years. We never needed workers because we weren't writing that much of it. Now everything just is so app-based that all of this needs to be structured better. We need that performance coming in, and things like this are really going to help. I mean, you take these people here, these people I work with, and they're lovely, we're called Live.js, they're all writing incredible pieces of software that play music and do visuals and control lights on stage in browsers and in Electron and things like that with JavaScript, right? So these are serious pieces of software, and things like workers and modules and stuff like that, it's just making things so much easier. Matt, for instance, top right there, he just moved everything over to using Rust and then just compiles, like he can compile it with WASM. It was like, I'm not really Live.js anymore, I'm like Live Rust. And we're like, that's fine, just WebAssembly that up, it'll be great. Yeah, all of this stuff is great. One thing that I do want to mention, I realize that this is like the shortest talk. I just went and run through it, it took 40 minutes. And you think that you don't do, I always do talks like this and I'm like, oh, no one is ever going to do audio visualizations. I had the absolute pleasure of working with Ada last year, at the tail end of last year. I loved the fact that she came on stage and she was like, this is the code for a 3D box, and like, it's super hard. And I'm like, she writes shaders in her sleep. We built an application which runs on an S8 phone in Samsung browser, which is an audio visualization application. And you can just get it on your phone and you can use it, and you can go to a Pi and you can project your audio visualizations, and you can create your own by editing the code. This actually does run on a 3D context, not on a 2D context, because we're having so many like performance problems when we first started, and because Ada's a genius when it comes to this stuff, basically. But check it out, just do a Google, just do VJ02G. You can actually just play around with the code, it's all on Glitch. Thank you very much. There's one more slide. Thank you very much.
Wow. It's working? Yeah. That was awesome. Thank you very much.
Thanks,
Thank you
Dave.
for waking everybody up. Everybody was bang on. So Ruth spoke 4 years ago. Our next speaker, Chris, spoke at State of the Browser in 2011. Is that right? Yeah. He had way more hair in those days. But time does things to us. And that's why the hair's one.
Yeah.
I'm just going to waffle. Hopefully he's going to talk us about the web audio API and show us some code that Ruth didn't get managed to write for us. That'll be fun. Chris works for Mozilla, and he works really, really well with the team at MDN. So every time that you Google something or duck something, and you have your answers about Stack Overflow, but the really, really important documentation that actually tells you really important things comes from MDN most of the time. So I'm going to hand you over to Chris. Thank you.
There we go. So, hey folks, thank you for coming today. Thanks for watching the talk. I've come all the way down from grimy Manchester to be here today. Saddleworth in particular, which is a beautiful part of the country, most famous because it's where Myra Hindley buried the bodies of their victims. But so, I'm here today to talk to you about design tools inside the browser. When I first started writing this talk, I thought, I've never seen Nyan Cat in a talk before. That'd be a really cool theme for a talk. And after a couple of beers, I just lost interest in that. And then I got the bring on the design tools, bring it on kind of thing in my head. So I decided then that I was going to start doing lots of action hero, Chuck Norris type shit for a talk theme. But then after a couple more beers, I got bored of that as well. So there is no theme for this talk, so apologies about that. Hopefully it will be useful to you. A little bit about me before we start. I've been at Mozilla for 5 years. I now manage and am content lead for the writers that write all of the content for MDN Web Docs. So we have a few full-time people and also a lot of awesome contractors like Ruth, being way too busy to do the stuff she enjoys because she's writing algorithms for me all the time. I'm a total open web evangelist, complete hippie guy. I love tinkering around with HTML, CSS, and JavaScript. A lot of my job used to involve reading specs and kind of figuring out how the hell they work and what the use cases are, writing demos and tutorials so that you folks can learn how that stuff works without going through the same pain. Now that I'm manager, it's basically getting complained at and filling in spreadsheets, but you know, it's okay. I am a total accessibility whingebag as well. I believe that even with all of the really cool, sexy new shit that we have on the web platform these days, the universal access aspect is probably still the sexiest thing about the web, so don't forget that. And outside work, I am a heavy metal drummer, so if you come and talk to me afterwards, please speak slowly. So I'm going to start this talk by looking into a little bit of the history of debugging in browsers and how we kind of got to where we are now. Not quite that far back, but my wife has said recently that Aidan Turner is the man she wishes she'd married, so Anyway, enough about that. Debugging was really hard in the early days of the web. I don't know if, who here was building websites like before year 2000? Show of hands. Yep, quite a lot of us. The old school folk. And we can remember back when there wasn't really much in the way of developer tools in browsers. We tended to do things like viewing source, although that didn't really teach you how stuff worked, so there was a lot of copying and pasting going on. We had what I like to call the 5,000 alerts method, which I kind of still use sometimes because, you know, you've got a simple piece of code, it's easier just to bung an alert in your JavaScript rather than setting up breakpoints and all of that crazy voodoo nonsense. There were older tools like Venkman. I don't know if anybody remembers Venkman. That was like an old JS debugger Firefox extension way back when. Did a bunch of stuff, but then after a while, of course, this little fella came along, Firebug, and it was absolutely awesome because, you know, it really kind of paved the way for what modern browser developer tools look like now. You know, you went beyond simple JS debugging to stuff like DOM inspection and CSS inspection and all of these nice things that we use these days. It had a whole lot of community power as well, which is really cool. You know, there was a whole team of volunteers coding the thing and also localizing it into all sorts of different languages. And it had a lot of users right up to the end. You know, it's like, in all of the kind of product shutdowns I've seen at Mozilla, this was one of the most sad and heartfelt ones, you know, because there was a lot of vitriol and a lot of really heart-rending moments talking to all these people that loved Firebug right up to the end. And of course, you know, we changed the entire extensions model, so it died because it will no longer work. But, you know, this is the way of the web. But yeah, native browser dev tools have become really slick and awesome. So, you know, we're doing well going forward. So I keep saying developer tools, but what about design tools? You know, what about tools specifically aimed at people who do design stuff like picking colors and looking at UI layouts and sort of, you know, more visual kind of interests? Because, you know, design on the web has got really exciting again. We have rounded corners, drop shadows, and I also saw that animated GIFs have become really popular again. I'm joking, of course. Okay, let's try that again. Design on the web has become really exciting again because of things like grid and flexbox for layouts, CSS shapes for much more interesting floating stuff that, you know, you don't just have to float things around rectangles anymore. That's really great. And variable fonts have just come into browsers recently as well, and that's really, really cool. But awesome features need awesome tools. You know, a lot of DevTools features traditionally have focused on the more kind of debugging JavaScript and network requests and all the tinkery type stuff, but, you know, designers don't want to just throw a bunch of commands into a console to get the results. They want tools that are a bit more comfortable and familiar and, you know, give them freedom to tinker around with tools, to tweak their layouts and things and get exactly what they want and save it back out again. I thought I'd say a little bit about this. Who remembers what this tool's called? Anybody? Yeah, Leah Verou's tool. It's called Dablet. Yeah. So this is something that the incredible Leah Verou wrote in about 2010, 2011. And this is the first time that we really saw kind of this, a glimpse into this kind of expressiveness that we now see in quite a lot of browser developer tools, or design tools, should I say. So if we just run that video again, you know, it's a kind of a code playground thing, but you've got these little pop-up boxes that say, you know, expressively, here's the result of what this property value will actually give you. So, you know, this was really cool and innovative, and in fact, some of the code straight out of Leah Verou's tools has been used in the Firefox design tools that I'm about to show you, because, you know, it's been very innovative and game-changing. So I've waffled on for maybe 8 to 10 minutes so far, but you still haven't seen any design tools. So let's bring it on. Oh yeah, I thought I'd mention a little bit of nomenclature first. So at Firefox in particular, we've started to break our tools down into 3 main types. So highlighters, you know, like things that highlight something that show you where it is, like the DOM highlighter. Inspectors, things that allow you to inspect exactly what's going on, so things like the grid inspector. And then you've also got editors, so things like the fonts editor, things that allow you to actually change code and get an immediate result in the browser. So let's have a little look at the grid inspector. So I'm about to do a bunch of live demos, which I know it's going to go up in flames, but we'll try it anyway. Let's have a little bit of a look at that. I've also got a really crap resolution now I'm presenting, so... And I've stolen a bunch of demos straight off Jen Simmons' site, which is great, because she's much better at writing this stuff than I am. There. We'll get this demo. So if we right-click on this, I know this was mentioned before, earlier on, but this is really, really useful, because you've got something with a grid on it. And I'll just zoom that in a little bit so it's a bit easier to see. So the main element is set as the grid container, so it's got a little grid label in the DevTools. Click on that, and it gives you the grid inspector, which shows you exactly where all of the different areas of the grid are, all of the different tracks and such like. But if you go into the layout panel, you'll see that you get this nice set of controls for doing things like displaying area names and line numbers and things, if that's useful to you. But you've also got this instant little visual readout here, which as you go across, it highlights all of the different parts of the grid to show you exactly where they are. And not only that, it gives you a tooltip to show you how big that grid is and what the area name is, what the row and column number is at the time. So that's pretty useful. We've also added RTL support for grids. So if we were to say, do direction RTL on here, oh, I've put direction, that's not going to work, is it? Sounds like some sort of Viagra-related project. Direction RTL, so there we go. So that turns it to an RTL layout. But you'll see now that if we go across from left to right on the actual grid thing, it's going from right to left on the actual layout. So it's quite useful to have that available if you work with such layouts. Ooh, that's tiny now. So moving swiftly on, I also wanted to say a little bit about the animation inspector. So CSS animations and web animations API stuff and transitions, these things are getting increasingly more complicated. So let's just look at what tools we've got to help with these. So I've got a bunch of bizarre variable font animation stuff in here. And if we inspect these, we will see that you've got an animation tab in the CSS rules view. And this gives you things like, so you probably can't read this too well, but we're saying here that we've got P with a class of animation property, which is where the animation is actually happening on, and it says the animation is called wait. And down here we can see we've got a wait CSS animation, and it says that this is animating font weight with a linear easing function, and it gives you all the information. So it gives you a similar thing for transitions, but the bottom one is animated using the Web Animations API, and you'll see here it's got those things listed in green, basically to differentiate and tell you it's a scripted animation. And what's even more interesting about this is if we go back to the animation property animation, it says here, so we've got a little swatch here next to our animation property, and if we click that, we've got a nice little animation timing function inspector that we can apply different animation timing functions and see the result live in the browser. And we can even drag these handles to alter the cubic Bezier curve, which is generating the timing function, and then we can see the code updating live in our CSS rules inspector. Now, to mention Leah Viera again, she had an awesome website called cubicbezier.com. I don't know if anybody saw that, but that was really cool and basically did the same sort of thing as this, and that actually uses code. This actually uses code taken from cubicbezier.com. I assume with Leah's permission. Who knows? So now let's talk a little bit about the font editor. Now this is one of the more exciting things for me. Like, I absolutely love variable fonts. I think they're a brilliant technology. The idea being that you can basically have one font file that will contain all of your font variations rather than having to download, say, your normal, your bold, your italic, your bold italic variants for doing different parts of your typography. And variable fonts include lots of different characteristics that vary on things called axes, and they allow you to basically specify ranges of values for things like weight and the angle of slant when you're doing an oblique font form and things like that. So if we have another little look at a different demo. No, that's not the one. Okay. So I'll just show you how this works. If we inspect this element, This is the paragraph that's got my variable font on it. So we click on the Fonts tab, and it gives us the name of the font. There's a bit at the bottom which tells us all the fonts on the page, along with things like the URL to the font file and the full font face at rule, so that you can see exactly what the code is looking like that brought that onto the page. But the most interesting part is this. So you'll see that you've got a slider for every single one of the different axes available in the variable fonts. So, for example, you can alter the font weight. And because of the way that variable fonts work, you've no longer got just like the multiples of 100 and keywords thing for your font weight. You can actually give it really granular values. But the way that the variable fonts specification stuff in CSS Fonts Level 4 works is that there's certain registered axes that are recommended that font designers should include, so things like slant, which means basically oblique, and font weight and such like, but the font designer can also include basically any custom axes that they want, so they can basically include absolutely anything. So if we look down here a bit, you'll see that in this font we can vary things like the ascender height and the descender height and the serif height and all of these different kinds of things. So yeah, you can build in anything you want. So it's useful to use this tool if you've maybe, got a copy of this font file that you want to use on your website from some reputable BitTorrent somewhere and you haven't got instructions for it. You can just load it up in here and see exactly the different axes that are available in the variable font. So moving swiftly on with my very eloquent product pitch, we have a shape path editor. So CSS Shapes, as you saw before, is a really interesting new spec that allows you to specify the shape of images, so you don't, and any other element on the page, in fact, so you don't just have to have things floating around rectangles. And so we've got simpler examples like this. This is again stolen from Jen Simmons' site. I'm sure she won't mind. And so we're using the shape outside property on this image and setting a circle to make it into a circle so that the orange, you can actually have the text just floating straight around the circular shape. But if you click the little shape icon there next to the shape outside property, you can get this up and you can just do things like vary the actual radius of the circle and the position of the circle. And then if we go too large, you can see that that's the actual outer limits of the actual image file itself, which is as far as you can go, which makes sense. But if you come across more complex examples, for example, this one, we've got a grape shape. And obviously you can't achieve this as a circle, so we're using the path function to do this. And this is basically works just like you'd expect from polygon function I meant. And it's basically just like an SVG path type thing. And if you activate the shape editor here, you get a point for each point around the path, and you can move all of these to change the position of your path. And you can even do things like add new points to the path by double-clicking along one of the lines, or you can delete them by double-clicking the points. So again, this is really rather useful for playing with this stuff. What else have we got? And how much time have we got? Ooh, 10 minutes worth. So the filter editor is what I'll talk about next. Filters are a really quite cool part of CSS now, coming into line with a lot of the more advanced graphical effects that people wanted. If we load up our filter example, this is a picture of my two daughters in their characteristically very serious kind of pose. But if we inspect this element, oops, we'll see that we've got a grayscale filter set on this image. If we click this icon here, this brings up the filters editor, and this has got a number of interesting features. So when you click and drag along the word of the filter, you can vary the values in real time just to get exactly the kind of look and feel you want. You can also add filters. So for example, hue rotate is probably one of my favorite ones. Let's put the grayscale down to 0, because with grayscale 100, hue rotate will not work. If we add that, you'll see that again we can start messing about with the different parts of the filter, and we can get a much more interesting look for my daughter's skin, which is pretty much how I imagine them to look anyway. So that's they are basically aliens. I don't really understand them anymore. So moving on, a very quick mention of 3-pane mode. You might have noticed that in these demos, we've had the CSS rules view in a separate pane to everything else. That's a recent addition to Firefox. You know, usually it's a separate tab under the CSS panel, but we've got this option now to put it out to its own separate pane, which is really useful and opens up all sorts of new interactions. You know, so if, for example, if you're using the font editor to mess about and edit your code, you can actually see the live update, but you can also see the code update at the same time. So that's really quite useful. Accessibility Inspector is the next one that I wanted to come on to. So this is a new tool, new as of Firefox 61, I believe, which allows you to inspect all of the information that is being exposed via the accessibility API in your sites. So if we just take this beautiful example I've got here, which has got great fonts because I have no internet. So if we right-click on this, we'll inspect this element, go to the accessibility panel, and to start off with, it doesn't do anything because you've got to turn it on. The reason you've got to explicitly turn on the accessibility inspector is because it needs all of the accessibility machinery in the browser to start up to actually expose all of the accessibility API's information that the screen reader will access and use in the case of people that use screen readers. But that's quite a big performance hit if you've got that turned on all the time, so that's why it's turned off by default. So you'll see here that this basically gives you the accessibility tree of the page, and you've got all of these different accessibility API nodes, accessibility tree nodes, should I say, in a hierarchy. And then if you click on each of these ones, you can basically get all of this information about each node on there. You know, what the actual DOM node that represents that is, what the ARIA role is, etc., etc., etc. So it's particularly useful for doing things like this. Where is it? My bad accessibility example. So here, you know, it's easy to, oh yeah, once you've got the accessibility inspector turned on as well, you've got a new right-click menu option, Inspect Accessibility Properties, which takes you straight to the accessibility inspector. And you'll see here that when we select our graphic, it tells us that we've got no alt text, for example. And when we right-click on these buttons, which are helpfully labeled fake buttons, as you're guessing, these aren't buttons, these are actually divs. But I think using divs for buttons is really cool, so, you know. So a few future things that we've got coming in the similar way to the CSS Grid Inspector. We've also got a Flexbox Inspector coming in the next couple of versions of Firefox. We've already got a Flexbox Highlighter available, but the full-on inspector will give you more of a Grid Inspector-like experience with Flexbox. We've got a bunch of interesting mobile debugging stuff coming up as well, so better remote debugging. We're also looking at not just having the stuff useful inside the browser, but also allowing it to be integrated into workflows. You know, for example, if you're using VS Code, soon you'll be able to actually have Firefox do remote debugging on things for you from inside VS Code, so that's pretty cool. And we've got an all-new responsive design mode with emulation for things like different throttling speed emulation and different device pixel ratio emulation, so that's pretty useful. But I could prattle on about other different tools forever and ever and ever, because there's so many of them. If you look at all of the other browsers as well, there's a lot of great tools coming in. I mean, I hardly ever use Safari. It's pretty much just a browser I occasionally just check a page in. But whilst I was researching this talk, I had a look at the Safari dev tools, and there's some amazing features in there. My favorite one was they have a really, really slick gradient editor in there now, so go and check that out if you have the time. And then there's some great drop shadow editors in Chrome as well, particularly close to my heart because drop shadows are awesome and you should use them for everything all the time. So, I'll just take a pause there for a second because that was a great big rant about DevTools. I just wanted to go through one more section. So, the idea of coping with loss. And I don't mean, I'm kind of talking about loss of a loved one. I'm basically talking about loss of code. So one thing that is nice about DevTools is, you know, it's a great educational tool. You can sort of just start messing about with the code live and teaching people about how certain properties work, for example. It's also great, as I've been saying, just to go through and, you know, I've got this layout and this setup, which is sort of what I want, but not exactly what I want. So I'm just going to go into the DevTools and tinker about with it until I get exactly what I want. But of course, all that hard work can be lost if you accidentally refresh the browser or completely, if the browser crashes or something. So there are tools to help with this. So Chrome has already got a tool called local overrides. Has anybody played with local overrides here? Yep, quite a few of you. So this is a fantastic idea. It's the idea that, you know, if you've got a website, you can basically specify a folder to save local overrides in, and local overrides are literally things like CSS files that when you enable local overrides and then start to make changes to your CSS file, it will save a copy of that inside the local overrides folder, so that when you've got local overrides turned on and you refresh the browser or restart it, it will then bring your changes back via this local CSS file. So that's really, really useful. And then we've also got a tool coming up in Firefox called Track Changes, which is going to be basically like a scrobble bar of the history of the stuff you've done inside DevTools, so you can return to any moment on it. We haven't got that anywhere near working properly yet, but it's coming. And that will allow you to persist things after refresh and restart as well. So I think this is kind of a very useful kind of interaction because, you know, count the number of times that I've lost useful code work because I've accidentally refreshed my DevTools or whatever. I'm sure most of you have the same kind of story. Okay, so that pretty much brings me to the end of the talk. I'd just like to say a big thank you to Jen Simmons for all the amazing demos. She is awesome. And also Martin and Razvan on the Firefox DevTools team for reviews and inspiration for this talk. So thank you very much, folks.
Chris, you've given me a problem.
Oh, not another.
So this morning, along came Dr. Ben, and Dr. Ben told me that I should change my browser because of privacy and all of those things. So I thought, yes, that's what I'm going to do. I'm going to move, and everything's going to be on Brave. And then Ada came along and said, but look at this, we can do WebXR in my browser. And it's like, okay, so now I'm going to go out, I'm going to buy a Android phone, and I'm going to install Samsung Internet, and I'm going to walk around like this and bump into things, but have an amazing experience. It's hurting my brain. And now Chris has come along, and he said to me, look at the amazing DevTools that we've got in our browser. And it's all like, now I'm just going to be having to switch between 5 different browsers every single day. And now we have Christian, and Christian works for Microsoft.
Yeah.
Christian has spoken at more State of the Browser events than any other speaker. So we welcome you back. Christian works for Microsoft. So he's going to now persuade me to probably go out and buy a new computer where I can install Microsoft Edge on it.
Chris.
But we'll see how that goes. Oh, over here. That's
you needed it.
There you go.
All right.
Cool.
Sorry, Chris.
As if by magic. So I'm going to hand you over to Christian. Thank you.
Hello. Now, I'm going to change the pace a bit here. I'm not going to show you the massively cool stuff that we have in Edge because all of you use Mac, so it's pointless. And I also don't want to talk about all the cool new ongoing technology stuff because you can see that anywhere where you're going anyways. I want to talk about a bit of a change that happened to me, and especially going back to the roots of State of the Browser, where we had different browser vendors sitting here telling us what's coming next and what we're doing for developers, and developers throwing abuse at us. And I want to talk about the change that happened to me when I moved from Mozilla to Microsoft, when out of a sudden I realized that there's this huge group of developers out there that don't go to these events, that don't read the coolest blog posts, but build things that people need every day. You know, like boring things like cache points, or like the tracking software of interstellar missiles, or, you know, insurance companies, these people that do the day-to-day web work that we actually see as boring, but use every single day. So talking to enterprise developers, I always thought it was Star Trek, but it's actually boring. And but I realized that we have a lot of things going on that we think the web is doing and we think browsers should be doing But I learned much more that working on a browser now and on a browser with clients that build things with the browser, that we have a very limited view of what the browser is doing. And as developers, we don't even understand just how much work we need to be doing. And we need to understand. So I was thinking about what can we do in terms of tooling to make this better. So what is the purpose of a browser? When I talk to myself, which I do a lot, in like 1997, 1998, when the IE6 thing died and other browsers came along, basically it was three simple things. It should render web content, it should show multimedia content, which was already a problem with like this video is not playable on your computer and these kind of things, and it follow and inspire web standards. I think we can agree that this is what browsers should be doing, or this was the good thing about them. This was about the time when the internet looked like that. This is what the browsers should be able to do. And I'm getting very tired of people having this limited view of what a browser is nowadays, because a browser is to me not only an interface for end users, but also a software platform. You use it inside things like Electron, you use it in like WebView apps that we had in 10,000 versions of Windows and in Firefox OS and these kind of things. So they're very complex pieces of software, and it's not only the things that we as web developers care about that browser vendors have to deal with. There's so much more happening right now, especially in the changed ubiquitous web that we have right now. We have the IoT, we've got laptops, we've got desktops, we've got tablets, we've got mobile phones, we've got voice interaction in browsers, we've got VR stuff going on. So as a browser vendor, you have to follow all these things and you have to understand all of them. And at the same time, you have to standardize them so you work with other browser makers, and you also have to deal with different clients with different needs. So the job of a browser, to me, changed drastically over the time that we had the web, and we always think we should push around the same things and say like, ooh, Chrome does this, you should do this as well. Safari does this, you should do this as well. But it's not a standard yet. It's a pseudo-standard. There's no such thing as a pseudo-standard. That's just a stupidity to me. So a browser needs to show web and multimedia content fast and reliably. And this is fun when you think about it, like, oh, cool. I remember when the first internet things went, and then the JPEG started loading, and I'm like, half an hour later, I'm like, it's a flower, isn't it? And now you see like people like, oh yeah, well, iPads don't play MP4 files or other video files, so I put a 14 meg GIF in there because it's funny. And when the browser uses like half your RAM because it renders a GIF that has been resized from this to there, it's the browser's fault. Give access to the web regardless of ability. Like browsers have to talk to assistive technology and have to actually talk to the operating system that makes assistive technology be able to turn something on the web to something readable, hearable, or understandable. We have to allow users to turn off animations, to support a high contrast view. We have to keep users safe by blocking unsafe content and patch attack vectors. We're all like, okay, cool, we got our ad blockers. But the amount of stuff that can be going wrong in browsers, Internet Explorer 6, 7, 8 had this great opportunity for JavaScript tinkerers that any PNG file with embedded JavaScript would execute that JavaScript. Which of course is great if you want to put a Bitcoin miner into somebody's Twitter account. So we also had Twitter resized our image by 1 pixel to make sure that actually code embedded would not be executed and these kind of things. Every time we create a new standard and we create something amazing, the terrible people of the web will use it first. Developers will say it's not ready yet, or we need an editor for it or something like that. I've seen about 40 different ways how to abuse web USB in terms of getting access to the computer. I haven't seen a sensible demo yet that really uses web USB for something good. Browsers have to remember users' history and access their credentials, or remember nothing. You have to have a private browsing mode, which is always a quite euphemism. We know what it's used for. Buying presents for your girlfriend so she doesn't know that you bought it, so it's not in your history. I don't know what you thought. But also, typing into something on my mobile phone is terribly annoying. Having an autocomplete for my emails, for my credit card numbers, for my telephone numbers, for my address is great. Unless only I get access to that, not somebody else with some random ad in a third-party JavaScript in the page. Allow for detailed customization, including extensibility. People want to change their browser to what they need. They want to have extensions on their browser. And extensions are the best way to get malware into a browser. And even extensions to developer tools had that problem in Chrome. You also want to sync content across a range of devices. You don't want to go to your mobile phone and start surfing and go to your desktop and keep going on surfing. But you don't want that data to be stored anywhere. So how should that happen? You can use audio API to use non-detectable sound to actually send data from one computer to another. But let's not do that. And browser makers have audiences with different needs. Everybody, as a web developer, and I myself had that thought, like, we should be the ones you care most about. Not really, because we're not the ones that bring them money. End users that click on their services inside their browsers make them money. Nobody makes money with a browser. Guess what they do? You do a search in the browser, a certain search engine is used, and that brings the money in. So consumers of the web are basically the biggest group we have out there. The people that just expect their data to be safe when they put it in a browser. The people just expect images to be loaded. The people just expect things to load fast, even if it's like 12 auto-playing ads in there and a parallax scrolling unicorn in the background in WebGL turning. Creators of web content are another audience as well. People want to make sure that they actually can create stuff for the web and it will not break in a new browser, because we've done that since 1997 and it shouldn't be any different. Web developers, of course, extension developers, app developers, and IT departments. That's one of my biggest problems working for Microsoft. You get like all excited about what we have in Edge, and then you go to a company and they're like, yeah, we only have Windows 7, we didn't upgrade to 10. Why? Because it was free? No, we just didn't have time to upgrade that. The other day I worked for a hardware maker, and we pressed a button and we updated 1.2 million computers in England to Windows 10, and that's a really good feeling. And there was 7 months of our work to be able to do that, to convince them that it's actually a better way to save money by having a better operating system that is better maintained. The other thing browsers need to do is be forgiving. Anyone is allowed to write code for the web, and that's great. Or use whatever they want to create that code. Yes, you can use a front page 1997 to still make a website, and we have to render that shit for you. Yes, the Space Jam website still exists. It has a link down there that says accessibility, that says, like, please tell us when something's wrong because we don't know how to make it accessible. And we still show it as the coolest thing that works since then. Whatever goes wrong, it's the browser's fault. That's always the thing. We love to point out to the browser, that's probably the browser doing it wrong. And you're like, you've got 12 animated GIFs on this page. Inside a parallax rotating in a cube. Why do you think that is slow? Users shouldn't suffer from developer errors. That's why JavaScript, that's why HTML and CSS have always been forgiving. Like, when you do something wrong, it goes on with it. JavaScript, you do one line wrong, it says like, that's the end of the world, fuck you, I don't want to work with you anymore. Legacy products will never get fixed. That's the other problem as well. Outdated browsers will be out there and they're not getting replaced no matter how free and open your browser is. And you can't break the web. The browsers are the ones that have to be backwards compatible in everything that they do. So when we innovate things, we have to make sure we innovate them and leave them. We can never take them away from you again, because then you get things like all the CSS substitution we had to do in Edge to make the web not break, that basically were wrongly done in Safari and then fixed in Chrome, but we still had to support all of them because people keep using them and they don't get maintained. So that created a messy web. The web has become a render target amongst many others. It's not people writing HTML, CSS, optimizing everything and then putting on their FTP and finding it out there. No, we just basically use 12 different libraries, press a button and hope everything works. And when we got 6,000 diffs in each other, it works, doesn't it? Who cares? Releasing often and developer convenience trumps semantics and performance of the final product. It was fun earlier when we looked at the divs of what the Twitter interface does. So, the Twitter interfaces change every 2 days. They don't want to make that thing maintainable. They don't care about the semantics. They don't care about the new feature coming in that makes sure that terrible people can talk to each other about racism or whatever the purpose of that thing is. So websites are slow and huge because they work on fast computers and good connections. We have these great connections, we have these great computers, so the things work great on our machines, and then we end users, they should just buy new computers, right? This is a quad-core i9 machine with 32 gig of RAM. The web looks good for now. Next week is probably slow. Being a web expert is less exciting than being a full-stack developer. I've been to a lot of conferences in the last years, and it gets less and less interesting to talk about cool web semantics and what CSS can do. But like, okay, you're a full-stack developer. You can be your Facebook founder tomorrow just by using these 5 libraries. People get super excited about running server to rendering and not understanding any of in between as long as it's fast. So how is it possible that the web is in this terrible state with all the great resources we have? We've got developermozilla.org, we've got caniuse.com that tells us what each browser can do and how it can be fixed if not. We've got Visual Studio Code and Atom and other hackable editors that are written in TypeScript. So if I want to fix them, I use the language that I use them for to fix the right, well, it's open source. But web developers, I think, need to know a lot these days and a lot more than we give ourselves credit for. We always say, like, okay, HTML, CSS, JavaScript, that's all it is. What is even JavaScript nowadays? You can do everything with JavaScript. So web developers need to know the performance of the website, how to make a performing website on a mobile phone, on a desktop device, on a HoloLens, wherever you want to run it. They need to know about accessibility. They need to know that a button should be a button, and if a button is not a button, it might not be available to the end user. They need to know interoperability. They need to know that that cool thing that is in this week's nightly build of Firefox is probably not going to be available for another 2 years in the other browsers, and you shouldn't rely on. They need to know about security. Even a blank target on a link is a security vulnerability nowadays. You gotta even look at the old HTML stuff and make sure you're not doing something wrong and you give something an opportunity to inject things. Internet Explorer used to have these filters in CSS. They were basically ActiveX controls inside your CSS, getting you full access to the graphics hardware, getting you full access to the machine. Houdini filters could do the same thing, but we learned from the mistakes that we did before. So every time we make something very interactive, we also can make it very insecure. We have to make things maintainable. The next developer needs to read your stuff and understand what you've been doing and actually making sure that they don't need to be as clever as you are to maintain the thing, because if you don't, then it's going to be a mess. I remember I did visitbritain.com back then. That was 127,000 pages in 73 languages. It was 14 templates in the content management system. The CSS was 300 lines of CSS. It was not much CSS that was supported back then. I left the company half a year later, 4,600 lines of CSS with like heading blue left aligned as class names and things like that. So the maintainability is something that we never think about, but we should. And that's only when it comes to building things for our end users. When it comes to being developers ourselves, we need to know about browser quirks, which browser messes up how. We need to know developer tool chains, what is broccoli, whatever tooling out there, you know, what kind of language do you use now? We need to know browser developer tools, like what can Firefox do, what can Chrome do for me, what can Edge do for me, what can Safari do for me. We need to know abstractions. Why is less not important anymore? Why is it Sass now? Why is it now Houdini? Why are all these things not the native CSS anymore? And we know the command line interface nowadays. The amount of times I hear, like, to be a CSS developer, you need to go to the Unix terminal. And I'm like, what? But we do. We have all these build tools that basically make us more effective, but we need to understand them. And we need to know about editors, which is the best editor and how to customize it for yourself to be more efficient. This is a lot to ask for just a web developer. Our world has become much more complex than it used to be. So where do you learn that? Standard documentation? Well, if you suffer from insomnia, it's a great thing to read through. Browser vendor docs? Cool, they're there, but they might be skewed towards a certain browser's ideas and their business models. Conferences? Sure, but it doesn't scale. This is affordable, it's great that you're here, but not everybody can go to a conference and has to beg their boss to actually get free time to go to conferences. Books? Outdated by the time they come out. Workshops? Even more time, even more expensive. Developer tools, great, they're in the browser, they do there, but again, they differ from one to another. And I switch between browsers, that costs me time, and it costs me cognitive overhead because I'm switching my mental model. News channels, good luck with that. So, what learning obstacles do we have as web developers? We have resources with upvoting options that favor the how over the why. That's your Stack Overflows, that's your W3C schools, W3 schools kind of thing. Like, all these solutions are never the answer and what the thing does, it's just like, do this and believe me. And you're like, okay, and that's why we mess things up with copy and paste development. We're not paid to learn, we're paid to deliver. Especially in a startup environment, you're not there to actually learn your trade. By the time you actually go through the interview, you're supposed to be the lead engineer. And they ask you like 3 whiteboard questions to test what you know, never seen you in production or whatever. Peer pressure makes developers who don't know things afraid to admit it. I hate that at JavaScript conferences when people are like, who here uses this kind of new API? Yeah, sure, for 5 weeks now. Nobody in the audience uses it, but nobody wants to be seen as the person who's not as cool as the others, and we're doing that to ourselves. That's stupid. There's always a good enough way to create a lot of in a short amount of time. Use Bootstrap. These kind of answers, you know? Let's do that. So what do? We take shortcuts. And this is where it gets really painful when I see, for example, AMP. People on the web standards love to rant about AMP, about being a terrible idea, and about being that like, oh, when I optimize it by hand, I'm actually faster than the AMP page. Yeah, but these are people who just want to deliver things. They don't want to know about these things. I'm not a fan of it either, but I understand that there was a need to make a performing thing, and they didn't want to learn through all the things, because most of our documentation when it comes to make a mobile performant HTML page is like, watch these 4 videos, each 1 hour long, that all disagree with each other how to do it properly. So, or use that thing that Google says it's the right thing to do. Tooling presets is another issue. Like, okay, here's a thing that like this build script creates these 5,000 things and then does the tree shaking and does the code splitting and makes it much easier for you as well. But it's still a 2 meg overhead for like a div that says hello world. But it's to make a tool and give it not a preset is a really hard thing to do, because people don't want to spend time customizing the tool. Abstractions, libraries, and frameworks, of course, a big thing as well, and hoping nobody cares is another big thing as well. Because if it runs fast on your boss's computer, who cares about the end users, right? So there's issues with current tooling that I have and other people had as well. First of all, there's too many promises. This tool makes $X easy, no need to look it up. This is always the thing that always cracks me up, like, accessibility is easy if you use this library, and you're like, no. But it's a message that is great, because people who just spend money on engineering basically love this kind of stuff. Huge Corp app uses this configuration and toolchain. If it works for their needs, it should rock for you too. Facebook uses React. Probably that website you're making for that florist should use React as well. Using this configuration optimizes for the modern web. That's what pisses me off the most. The expression the modern web is the most nonsensical thing I know. What is the modern web? The modern web used to be filters in CSS in Internet Explorer 6. The modern web used to be Flash. The modern web used to be like whatever. It's like modern is a thing that's moving so fast. It's a very good headline. It sells you things, but it's a very stupid thing to say, because the modern of today becomes the security bug of tomorrow. There's too many rules and barriers for us to start thinking things. Opinionated tools demand you to fix things that don't apply to your product. Like, to get 100% in this testing tool, you need to have a web worker, a service worker, and a manifest, because otherwise you're not PWA compatible. Well, I'm building an internet page. It doesn't have to be PWA compatible. I never need a service worker for anything. But the tool tells me, unless I do that, I don't go through the build script, it doesn't get live. Dependencies and complex toolchains can be daunting. It's like, okay, learning these kind of things, especially by the time when somebody says, that's the coolest thing ever, and then I'm on a plane, and it takes me 4 or 5 days, and by the time I get time to look at it, their next blog post like, don't use that, it's not good enough anymore. And you're like, what am I doing here? Best practices often don't get updates and are contextual. What's a best practice for Google or for Microsoft is not a best practice for Facebook, for Twitter, or for other people, or for Walmart. Having to follow strict rules without understanding them is not fun. You need to set this on your server to have that broadly compression and this kind of thing, and you're like, why? Well, otherwise you don't follow. Otherwise it's not a modern web kind of thing. So you don't want to feel stupid by using a tool. So how can we accelerate that learning? And that's something that I've been working on a lot lately, especially with partners, with clients that have like 9 to 5 developers, what we keep calling the black hole developers that nobody ever sees. They just go into the office, build code for 9 hours and go home. And never go to any conference, never read any blog posts, never care about it. They just want to do their job. So I think the customizable best practices in context is the only way we can reach those people, and we can make ourselves much happier as well. So what does that mean? Having information isn't enough when people don't go there. It's great that we have the MDN web docs, but if you don't have time to look things up, and you basically just want to have it in your editor, you should have it in your editor. We need to prevent mistakes before they happen. So debugging is great. Linting before you do something stupid, typing something in and it get a squiggly red line under it, that's a good thing too, because then you don't have to go through the debugging process and you have to understand what debugging is as well. Much like having a spell checker in Word is great, because while I'm typing thing, it tells me this sounds stupid, that's a mistake. And we should do the same with code. We need to allow people to customize this experience. An intranet site, for example, needs different settings than a marketing site. And let's target editors, I think, and build processes. We have all these cool build processes. We got our Webpack, we got our grunt, gulp, broccoli, fart, whatever. So let's make sure that the best practices that we have on the web and what leads to good outcome is part of these things. So linting and inline insights into editors is a great thing. I love that I write CSS in Visual Studio Code and it tells me up there, these are all the things that are wrong. And if I disagree with some of them, I can change the JSON notification of my linter and say, like, don't tell me about that. I know it's wrong for some, it's good for me. So you can turn those things off. So one thing that we put together is WebHint.io, which used to be called SonarWall, and then there was a copyright issue, and there was Sonar, there was another copyright issue, and we don't know what WebHint is going to be. But right now it's WebHint.io. And there you can go and put a URL in, and it does all the checking for you. So this sounds like a magical thing, but bear with me, because it actually follows to the things that I just said. So what you do is you do example.com, which I think, after all the time that we've done on the web, should be error-free, right? It's only it's a white web page saying example.com on it. But if you look through it, we actually found an accessibility error, we found interoperability errors, we found 2 performance errors, we found PWA error and 2 security warnings just in that URL. And the great thing about that tool is not it just tells you like you've done something wrong, but you can click through it and it explains to you what the things are wrong. So interoperability, it didn't have the UTF-8 header on the client side, it expected the browser to do it right. And some mobile browsers don't do the UTF-8 configuration for you, which means the text is being displayed wrongly, and it also allows you to inject things into form fields that you shouldn't be able to inject if the font setting hasn't been done properly. And then when you click through even more details, then it explains to you why this is a problem, why it is important, how to fix it, and where to find more documentation around it. And this is the thing that I miss a lot of other these tools. They say like, it's wrong, but why? Well, you're stupid enough, you're not clever enough to know how to fix it kind of thing. Of course, I ran stateofthebrowser.com, and I have to say, we have no accessibility errors. That's pretty cool. We got a few interoperability, a PWA, performance, and security. But there's the interesting thing. Why should I care? What if I don't care about PWA? I still have the terrible report that I can't show to my boss because there's 2 errors in there. Because oh, you didn't do it right then. So you can actually configure all of that. And even more important, you can hint during deployment. So instead of having this just a website where you have to go and type the URL in your build script you can put WebHint in. You can also put Google stuff in there as well if you wanted to. And it becomes part of your continuous integration. It becomes part of your building. So WebHint is node-based, so you can install it as a part of your build deployment process. And you can also give you detailed information about the setup of your bundler pre-process to avoid huge release sizes. So if you use Webpack, and out of a sudden you realize you got 3 meg of JavaScript and you don't know why, WebHint also analyzes that part of the development process, not only the HTML, CSS, and the JavaScript that get generated, to optimize that view. So again, it's just a node module. You say hint example.com, you get the message out there, and you can generate an HTML report, a CSS, CVS report, or just in this case, show it in the terminal. We've built this mostly for third-party companies that build stuff for us, and we told them we cannot release this because it's insecure, and they're like, how is it insecure? And now we send them just these reports. So you got hints on performance, accessibility, PWA readiness, development environment, interoperability, and security. You can set them any way you want to. So if your environment does not need the PWA readiness, you can change the configuration and say I don't want that test, please don't show that to me. So you customize the hint yourself, and you can develop them yourself. This is a guided thing inside Node. If you just go on the in the Node thing right now and you say create a new hint, that GIF doesn't work. But it basically gives you a yes/no question. Is this part of this? Is this part of that? Is this part of that? What are the rules you want to test? What are your tests? And what is the message at the end? So you can customize them to your need. So I think this is a great way to create a better web independent of browser or OS, because we have one resource that does all these cool resources that we have. We're using Axe for the accessibility stuff, we're using SNCC for the security things, and we made it available and readable and understandable to you in one single tool. You can create detailed reports for third-party products about broken issues. You can customize your hinting to allow it to your needs. You can and it's open source. So it's not a Microsoft product, it's actually from the JavaScript Foundation. We donated that because we don't want to be that people like, oh, I hate it because it's Microsoft. Fine. And that's all I had. So take a look at that. Think about what we need to know as JavaScript, as web developers, and think about, do you want to spend all the time learning all these things, or have a testing tool that explains you what's going wrong while you're writing code? Thanks very much.
Thank you very much. I noticed that it's taken until 3:30 in the afternoon to get unicorns on the screen. A-star. Thank you very much, Christian. We're going to take a little break for 20 minutes. We're going to come back at 4 o'clock. Okay, bang on 4 o'clock. I'm not going to tell you how long, because that's wrong. 4 o'clock. I'll see you back in here. Thank you. amazing. I've learned new things. I've got excited about things again. It's just, we've got to that point now that I'm getting more excited. We'll talk about that in the pub. But before I introduce our next speaker, who you probably know anyway, but at the end, please do a number of things for us. Please don't leave anything lying behind, because your stuff is your stuff and you should take it away with you. At the back, there is apples, bananas, and things like that. If you don't take them, we have to find some way of getting rid of them. So please take something. There's bottles of water, take them. You'll need some water at some point in the next few days. So please make sure that all of those things just magically disappear to make our lives a little bit easier at the end of the day, because we want to get to the pub to chat with you as well. So please do help with that. Okay. Last night, we took the speakers out for some Vietnamese food. It was great. And I spent a lot of time listening to Jeremy and what he had to say. And I thought, what am I going to say to introduce Jeremy? So I boiled it down to this. Jeremy.
Thank you. Thank you, Dave, for that lovely and succinct introduction. Hello, everyone. Okay, good. Thank you for still being here. We're on the final stretch now. I am here today to talk to you about the web, and more specifically, about web standards. Here's the thing about web standards. Web standards don't exist. At least they don't physically exist. They're intangible. But they're in good company. Feelings are intangible, but real. Hope, despair. Ideas are intangible. Liberty, justice, socialism, capitalism, the economy, currency, all intangible. I'm sure we've all had those college thoughts, right? Money isn't real, man. It's just bits of metal and paper. Wake up, sheeple. Nations are intangible. Geographically, France is a tangible physical place, but France, the Republic, is an idea. And geographically, North America is a real tangible physical landmass, but ideas like Canada and the United States only exist in our minds. Faith, the feeling, is intangible. God, the idea, is intangible. Art, the concept, is intangible. A piece of art is an instantiation of the intangible concept of what art is. Incidentally, I really like Brian Eno's definition of what art is. He says, art is anything we don't have to do. We don't have to make paintings or sculptures or films or music. We have to clothe ourselves for practical reasons, but we don't have to make clothes beautiful. We have to prepare food to eat it, but we don't have to make it a joyous event. Also, by this definition, sports are also art. We don't have to play football. Sports are also intangible. A game of football is an instantiation of the intangible idea of what football is. Football, chess, rugby, Quidditch, and rollerball are all equally intangible. But football, chess, and rugby have a bit more consensus. Just like Christianity, Islam, Judaism, and the Force are equally intangible, but Christianity, Islam, and Judaism have a bit more consensus than the Force. HTML is intangible. A web page is an instantiation of the intangible idea of what HTML is. But we can document our shared consensus. A rule book for football is like a web standard specification, a documentation of consensus. And by the way, economics and religions and sports and laws, they're all examples of intangibles that can't be proven because they all rely on their own internal logic. There's no outside data that can prove football or Hinduism or capitalism to be true. That's very different to ideas like gravity, evolution, relativity, or germ theory. They're all intangible but provable. They're discovered rather than created. They're part of objective reality. Consensus reality is the collection of intangibles that we collectively agree to be true. Economy, religion, law, web standards. Now, we treat consensus reality much the same as we treat objective reality. In our minds, football, capitalism, and Christianity are just as real as buildings, trees, and stars. And sometimes, consensus reality and objective reality get into fights. And some people have tried to make a consensus reality around the accuracy of astrology or the efficacy of homeopathy or ideas like the Earth being flat, 9/11 being an inside job, the moon landings never having happened, the Holocaust never having happened, or vaccines causing autism. And these people are unfazed by objective reality, which disproves each one of these ideas. Now, it used to be that for a long time the consensus reality was that the sun revolved around the Earth. And Copernicus and Galileo demonstrated that the objective reality was that the Earth and all the other planets in our solar system revolve around the sun. Now, after the dust settled on that particular punch-up, we switched up our consensus reality. We changed the story. Because that's another way of thinking about consensus reality. Our currencies, our religions, our sports, and our laws are stories that we collectively choose to believe. Web standards are a collection of intangibles that we collectively agree to be true. There are stories. There are collective consensus reality. They're what web browsers agree to implement and what we agree to use. The web is agreement. Now, for human beings to collaborate together, they need a shared purpose. They must have a shared consensus reality, a shared story. And once a group of people share a purpose, they can work together to establish principles. Design principles are points of agreement. There are design principles underlying every human endeavor. And sometimes they're tacit and sometimes they're written down. And patterns emerge from the principles. Here's an example of a human endeavor, the creation of a nation state like the United States of America. The purpose is agreed in the Declaration of Independence. The principles are documented in the Constitution, and the patterns emerge in the form of laws. HTML elements, CSS features, JavaScript APIs are all patterns that we agree upon. And those patterns are informed by design principles. Now, I've been collecting design principles of varying quality at principles.adactio.com. And here's one of the design principles behind HTML5. It's my personal favorite. It's the priority of constituencies. In case of conflict, consider users over authors, over implementers, over specifiers, over theoretical purity. In case of conflict, that's exactly what a good design principle does. It establishes the boundaries of agreement. If you disagree with the design principles of a project, there probably isn't much point contributing to that project. Also, it's reversible. You could imagine a different project that favored theoretical purity above all else. In fact, that's pretty much what XHTML2 is all about. XHTML1 was simply HTML reformulated with the syntax of XML. Right? Lowercase tags, lowercase attributes, always quoting attribute values. Remember, HTML doesn't care whether tags are uppercase or lowercase, or whether you put quotes around your attribute values. You can even leave out some closing tags. So XHTML1 was actually kind of a nice bit of agreement. Professional web developers agreed on using lowercase tags and attributes, and we agreed to always quote our attributes. Browsers don't care one way or the other. But XHTML2 was going to take the error handling model of XML and apply it to HTML. And this is the error handling model of XML. If the parser encounters a single error, don't render the document. Of course, nobody agreed to this. Browsers didn't agree to implement XHTML2. Developers didn't agree to use it. It ceased to exist. Because it turns out that creating a format is relatively straightforward. But how do you turn something into a standard? The really hard part is getting agreement. Sturgeon's law states that 90% of everything is crap. Coincidentally, 90 is also the percentage of the world's crap that gets transported by ocean. Your clothes, your food, your furniture, your electronics, chances are that at some point they were transported within an intermodal container. And these shipping containers are probably the most visible, certainly one of the most important standards in the physical world. Before the use of intermodal containers, loading and unloading cargo ships was a long, laborious, and dangerous task. Along came Malcolm McLean, who realized that the whole process could be made an order of magnitude more efficient if the cargo were stored in containers that could be moved from ship to truck to train. But he wasn't the only one. The movement towards containerization was already happening independently around the world. But everyone was using different sized containers with different kinds of fittings. And if this continued, the result would be a Tower of Babel instead of a smoothly running global logistic chain. Now, Malcolm McLean and his engineer, Keith Tattlinger, designed two crate sizes, 20-foot and 40-foot, that would work for ships and trucks and trains. And their design also incorporated an ingenious twist lock mechanism to secure containers together. But the extra step that would ensure that their design would win out was this. Tattlinger convinced McLean to give up the patent rights. Now, this wasn't done out of hippy-dippy ideology. These were hard-nosed businessmen. But they understood that a rising tide raises all boats, and they wanted all boats to be carrying the same kind of containers. And without the threat of a patent lurking beneath the surface, ready to torpedo the potential benefits, the intermodal container went on to change the world economy being very large and intangible. The World Wide Web also ended up changing the world economy and much more besides. And like the intermodal container, the World Wide Web is patent-free. Again, this was a pragmatic choice to help foster adoption. When Tim Berners-Lee and his colleague Robert Caillou were trying to get people to use their World Wide Web project, they faced some stiff competition. Lots of people were already using Gopher. Anyone remember Gopher? Wow. And the seemingly unstoppable growth of Gopher was somewhat hobbled in the early 90s when the University of Minnesota announced that it was going to start charging fees for using it. And this was a cautionary lesson for Berners-Lee and Caillou. They wanted to make sure that CERN didn't make the same mistake. So, on April 30th, 1993, the code for the World Wide Web project was made freely available. This is for everyone. If you're trying to get people to adopt a standard or use a new hypertext system, the biggest obstacle you're going to face is inertia. As the brilliant computer scientist Grace Hopper used to say, the most dangerous phrase in the English language is, "We've always done it this way." Now, Rear Admiral Grace Hopper waged war on business as usual. She was well aware how arbitrary business as usual is. Business as usual is simply the current state of our consensus reality. She said, "Humans are allergic to change. I tried to fight that. That's why I have a clock on my wall that runs counterclockwise. But think about it, our clocks are a perfect example of a ubiquitous but arbitrary convention. Why should clocks run clockwise and not counterclockwise? Well, one neat explanation is that clocks are mimicking the movement of shadow across the face of a sundial in the northern hemisphere. And had clocks been invented in the southern hemisphere, they would indeed run counterclockwise. But on the clock face itself, why do we carve up time into 24 hours? Why are there 60 minutes in an hour? Why are there 60 seconds in a minute? Well, it probably all goes back to Babylonian accountants. Early cuneiform tablets show that they used the sexagesimal system for counting. It's because base 60, 60 is the lowest number that can be evenly divided by 6, 5, 4, 3, 2, and 1. But we don't count in base 60. We count in base 10. I mean, that in itself is arbitrary. We just happen to have a total of 10 digits on our hands. So, if the sexagesimal system of telling time is an accident of accounting, and base 10 is more widespread, why don't we switch to a decimal timekeeping system? It has been tried. The French Revolution introduced not just a new decimal calendar, much neater than our base 12 calendar, but also decimal time. Each day had 10 hours. Each hour had 100 minutes, and each minute had 100 seconds. So much better. It didn't take. Humans are allergic to change. And sexagesimal time may be arbitrary and messy, but we've always done it that way. It's also why I'm not holding my breath in anticipation of the USA ever switching to the metric system. Instead of trying to completely change people's behavior, you're likely to have more success by incrementally and subtly altering what people are used to. And that was certainly the case with the World Wide Web. The hypertext transfer protocol sits on top of the existing TCP/IP stack. The key building block of the web is the URL. But instead of creating an entirely new addressing scheme, the web uses the existing domain name system. Then there's the lingua franca of the web. And these elements probably look pretty familiar to you, right? You recognize this language, right? Right. It's SGML. Standard Generalized Markup Language. Specifically, it's CERN SGML, a flavor of SGML that was already popular at CERN when Tim Berners-Lee was working on his World Wide Web project. And he used this vocabulary as a basis for the hypertext markup language. And because this vocabulary was already familiar to people at CERN, convincing them to use HTML wasn't that much of a hard sell. They could take an existing SGML document, change the file extension to .htm, and it would work in one of those newfangled web browsers. In fact, HTML worked better than expected. The initial idea was that HTML pages would be little more than indices that pointed to other files containing the real meat and potato of content, spreadsheets and word processing documents, whatever. But to everyone's surprise, people started writing and publishing content in HTML. And was HTML the best format? Far from it. But it was just good enough and easy enough to get the job done. And it has since changed. But that change has happened according to another design principle. Evolution, not revolution. From its humble beginnings with that handful of elements borrowed from CERN SGML, HTML has grown to encompass an additional 100 elements over its lifespan. And yet, it's technically the same format. And this is a classic example of the paradox called the ship of Theseus, better known in this country as Trigger's broom. You can take an HTML document written over 2 decades ago and open it in a browser today. Even more astonishing, you can take an HTML document written today and open it in a browser from 2 decades ago. And that's because the error handling model of HTML has always been to simply ignore any tags it doesn't recognize and render the content inside them. And that pattern of behavior is a direct result of the design principle, degrade gracefully. Document conformance requirements should be designed so that the web content can degrade gracefully in older or less capable user agents, even when making use of new elements, attributes, APIs, and content models. Here's a picture from 2006. That's me in the cowboy hat. This picture was taken in Austin, Texas. It's an impromptu gathering of people involved in the microformats community. And microformats, like any other standards, are sets of agreements. In this case, they're agreements on which class values to use to mark up some of the missing elements from HTML. People, places, events, that's pretty much it. And yes, they do have design principles, some very good ones, but that's not why I'm showing this picture. Some of the people in this picture, Tantek Chelik, Ryan King, and Chris Messina, were involved in the creation of Bar Camp, a series of grassroots geek gatherings. And bar camps sound like they shouldn't work, but they do. The schedule for the event is arrived at collectively at the beginning of the gathering. It's kind of amazing how the agreement emerges. Rough consensus and running events. And in the run-up to Bar Camp in 2007, Chris Messina posted this to the fledgling social networking site twitter.com. How do you feel about using pound for groups, as in pound bar camp? This was when tagging was all the rage, right? We were all about folksonomies back then. And Chris proposed that we would call this a hashtag. Now, I wasn't a fan, but it didn't matter what I thought. People agreed to this convention. And after a while, Twitter began turning the hashtagged words into links. And in doing so, they were following another HTML design principle: pave the cowpaths, which sounds like advice for agrarian architects, but it is further clarified. When a practice is already widespread among authors, consider adopting it rather than forbidding it or inventing something new. Now, Twitter had previously paved a cowpath when people started prefacing usernames with the apparand symbol. And that convention didn't come from Twitter, but they didn't try to stop it. They rolled with it and turned any username prefaced with an @ symbol into a link. And the @ symbol made sense because people were used to it from email. And the choice to use that symbol in email addresses was made by Roy Tomlinson. He needed a symbol to separate the person and the domain. And he looked down at his keyboard, he saw the @ symbol, and he thought, that'll do. And perhaps Chris followed a similar process when he proposed the symbol for the hashtag. It could have just as easily been called a number tag or an octothorpe tag or a pound tag. And this symbol started life as a shortcut for pound, or more specifically, Libra Pondo, meaning a pound in weight. And Libra Pondo was abbreviated to LB when written. And that got turned into a ligature when written hastily. And that shape was the common ancestor of two symbols we use today: pound and pound. And the 8-pointed symbol was perhaps jokingly renamed the octothorpe in the 60s when it was added to telephone keypads. And it's still there on the digital keypad of your mobile phone. And if you were to ask someone born in this millennium what that key is called, they would probably tell you it's the hashtag key. And if they're learning to read sheet music, I've heard tell that they refer to the sharp notes as the hashtag notes. And if this upsets you, you're probably the kind of person who rages at the word literally being used to mean figuratively, or supermarkets with aisles for 10 items or less instead of 10 items or fewer. Well, tough luck, because the English language is agreement. And that's why English dictionaries exist, not to dictate usage of the language, but to document usage. And it's much the same with web standards. They don't carve the standards into tablets of stone and then come down the mountain to distribute them amongst the browsers. No, it's what the browsers implement that gets carved in stone. That's why it's so important that browsers are in agreement. In the bad old days of the browser wars of the late 90s, we saw what happened when browsers implemented their own proprietary features. Standards require interoperability. Interoperability requires agreement. All right, so what can we learn from the history of standardization? Well, there's some direct lessons from the HTML design principles, like the priority of constituencies. Listen, I want developer convenience as much as the next developer, but never at the expense of user needs. And I've often said that if I have the choice between making something my problem and making it the user's problem, I'll make it my problem every time. That's the job. And I worry that these days, developer convenience is sometimes prized more highly than user needs. I think we could all use a priority of constituencies on every project we work on. And I would hope that we would prioritize users over authors. Degrade gracefully. I know I go on and on about progressive enhancement a lot. Sometimes I make it sound like a silver bullet. Well, it kind of is. I mean, you can't just buy a bullet made of silver. You have to make it yourself. And if you're not used to crafting bullets from silver, it will take some getting used to. Again, if developer convenience is your priority, silver bullets are hard to justify. But if you're prioritizing users over authors, progressive enhancement is the logical methodology to use. And it's a testament to the power and flexibility of the web that we don't have to build with progressive enhancement. We don't have to build with a separation of concerns like structure and presentation and behavior. We don't have to use what the browser gives us. Buttons, drop-downs, hyperlinks. If we want, we can make those things from scratch using JavaScript, divs, and some ARIA attributes. But why do that? Is it because those native buttons and drop-downs might be inconsistent from browser to browser? Consistency is not the purpose of the web. Universality is the key principle underlying the web. And our patterns should reflect the intent of the medium. Use what the browser gives you. Build on top of those agreements. Because that's the bigger lesson to be learned from the history of web standards and clocks and containers and hashtags. Our world is made up of incremental improvements to what has come before. And that's how we will push forward to a better tomorrow, by building on top of what we already have, instead of trying to create something entirely from scratch. And by working together to get agreement, instead of going it alone. The future can be a frightening prospect. And I often get people asking me for advice on how they should prepare for the web's future. And usually they're thinking about which programming language or framework or library they should be investing in. But those specific patterns matter much less than the broader principles of working together, collaborating, and coming to agreement. And it's kind of insulting that we refer to these as soft skills. They couldn't be more important. And working on the web, it's easy to get downhearted by the seemingly ephemeral nature of what we build. None of it is real. None of it is tangible. And yet, looking at the history of civilization, it's the intangibles that survive. Ideas, philosophies, cultures, and concepts. And the future can be frightening because it is intangible and unknown. But, like all the intangible pieces of our consensus reality, the future is something we collectively construct through agreement. Now let's agree to go forward together and build the future web. Thank you.
Thank you. Our next speaker, I've known Charlie for many, many, many years. So much so, we used to go walking around London, looking at where people have died for a hobby.
Oh, that was great, wasn't it?
It was so much fun. We'll talk about that in the pub if you're interested. But yeah, we drank quite a lot of beer together and all sorts of things like that. But earlier this year, when we're originally thinking about State of the Browser, Charlie posted this blog post, and before I'd even finished reading it, I sent him a message on Twitter saying, "You have to come to Web Standards and talk about that blog post."
That money I sent you worked then?
Yeah, it did.
Fantastic.
It did. Yeah.
Yeah.
So, yeah, Charlie.
Hello. Hello there. Yeah, this is actually a real honor for me because the first ever web conference I went to was State of the Browser back, 8 years ago? I can't even remember when it first started. So, 2011. So to speak at this now is like a full circle for me. You know, it's like a little heart thing going on. But anyway, first of all, who the hell am I? Because, you know, it's okay, you should ask that. I ask that myself a lot. I don't really know. It's okay. I'm still trying to figure it out. But I have been in this industry for 20 years now. I've been orbiting in and out of it. You know, I've kind of dipped in at times and come out again and got bored and come back. But I most recently re-entered about 7 years ago, and I absolutely love it because this is a really interesting time. And as you may be able to tell from my accent, I am actually from the British Isles, you know. I was born here, but I don't live here anymore. I got out early, and I moved to Berlin in Germany, which is an absolutely beautiful place. It's a place of real sophistication, place of, you know, really top quality gourmet food. It's a place of restraint and privacy. No, I adore that. It's such a change after London. And it's incredibly stereotypically German, which I absolutely love. It's all about the lederhosen and order there. And there in Berlin, I work for a company called Springer Nature. I'm the lead front-end developer in their Berlin department. And some of you might not have heard about Springer Nature. You know, don't worry if you haven't. There's not much reason you would have done. But it's actually one of the largest scientific publishers on the planet. It's been around since like 1869 or something like that. It's a really big deal. It's an old place. And it publishes things like Biomed Central, Scientific American, and the eponymous journal Nature, which you've probably heard about. You see it referenced in news reports all the time. The kind of place where if you get published in there, your career is made. And Springer Nature is all about helping scientists to get their work seen by other scientists. Those are all real scientists. I checked this. Google told me so. But I'm not here to talk to you about science. I really wish I was. I don't know anything about science. But I'm actually here to talk to you about the single biggest invention in recent human history. So I think that's no biggie, you know, we can do that in half an hour. But that thing is the web, the stuff that Jeremy's just told us all about. And talking about Jeremy, I read his book. It was absolutely fantastic. So I decided to steal huge chunks of his content and put it into slides and use it. It was it's a real honor to take his work in that way and reuse it. But the web's incredible because it is stupid. Or at least, it's a bunch of stupid technologies. Stupid technologies that are all bunched together and made to work together. And I want to just give you an incredibly simplified history about it, just so we can see what we're on about with this. And I think you can easily say that the history of the web started, you know, like the pre-history of the web started with things like telegraphs. You know what those are? The little beep, 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 beep things, you know, that communicated data all over the world? Well, these things got upgraded. They got upgraded into things called telephones, so instead of having arguments by dots and dashes, we could have arguments via our voices instead. And then the first primitive computers started to use these amazing new telephone things to have conversations between themselves. I'm sure you've seen the movie War Games, you know how that story ends out. And because they were talking to each other, just like Jeremy said, some of the agreement was needed, so we came up with all these network protocols to make things work together. TCP, IP, UDP, all working together. And then all these local networks that were kind of talking to each other, suddenly started talking en masse with each other. And we had the interconnected global network, the internet, the foundation for everything else that would come. And then on top of that, we built application protocols because we needed more standards to make things work better. Email and SSH and FTP, stuff we're all familiar with today. And we needed ways of identifying where we would find stuff. Jeremy talked again about the @ symbol. And so we started using it, and what the hell is happening to democracy at whitehouse.gov, things like that. Oh. And then finally, we had HTML, which was built on top of the HTTP protocol that we talked about. Vague but exciting, as Tim Berners-Lee's supervisor said. Completely missing the boat on that one. Oh, my controller has just gone mad. Sorry. And I mention all of this, I talk about all these things because the web is incredibly strong. And we never, ever stop to appreciate this. And it's strong because of the simplicity of all those little technologies put together, layered on top of one another, each one making use of the layer before it. Especially HTML itself, which is it's a simple declarative language, something that we use all the time, but it's a simple declarative language. And we never stop to think what declarative means in this context, do we? Because, it's very easy to say, oh, HTML is a declarative language, but what does that mean? Well, to me, it means that HTML is flirty. It's a little bit flirty. It likes to call up the browser late at night and say things like, hey, baby, how's it going? I was totally thinking we could get some paragraphs and a header on page. Could you do that for me, And the browser's like, oh my God, yeah, this is amazing. Yeah, I'll totally do that for you. And it agrees to do it. And this flirtation, this requesting of things makes the web incredibly strong. Because you see here, I'm running the Amazon data website, and I'm pulling out chunks of the code from the page as it is running. Can we take a second and think how incredible that is? We can pull out chunks of a running web page, and yet right at the end, I can still click on the shopping cart icon and carry on, as if nothing had happened. That's incredible. And that strength and that robustness is why the web is so popular nowadays, why it is everywhere in our lives. It's in every pocket. It's on every refrigerator, it feels like. It dominates because it is robust. Because it was born into this weird heterozygous world of muddy waters and grey areas where things could not be relied upon. It's robust. And the things it does could not be done by a strict language. Absolutely no way. A strict language would fall over and die in this position. And it's not the only reason why the web is popular, of course. Again, we just heard from Jeremy, we've heard from other people about Tim Berners-Lee giving up all the intellectual property rights on the web and making it available to everyone. Anyone can build a browser. Anyone can download a browser. There's no restrictions for any operating system. You can do this. And this meant that the early web, right from the start, was an absolutely bizarre place, filled with weird shit all over there. It was a place where you could declare your love for your favorite pop star. Where, struggling authors could get their start in the world, and tiny little startups could have a crack at this whole web thing and see if it took them anywhere. The early web was incredible. I'm so privileged I got to see it the first time round. But, I'm going to use the word but a lot in this talk. The bad times are sure to follow, aren't they? Any of the good times, there's always going to be some bad times. And what was once free and weird slowly became commercialized and balkanized and locked in. Again, I don't know if anybody can remember these two browsers, but at one point, the web got split between them effectively. Developers had to write their code so that it worked on either of their browsers. You had different forks for different browsers. Your JavaScript, or, well, not JavaScript, DHTML as we called it in those days, had to work in one of them. And people had to declare their loyalty by putting little banners at the bottom of their page. This page is best viewed in Internet Explorer or Netscape Navigator 4.7. Make sure you're using at least 800 by 600 pixels. And this led to a complete lack of innovation for a while. Again, anyone who was around in that period can remember the time when we felt like we were stuck with Internet Explorer 6 for decades, it felt like. When nothing changed, nothing interesting happened. But this period of innovation freezing changed because of this device, I would argue. This unexpected direction. Because the iPhone appeared, didn't it? And it completely upset all of our expectations about how things should be. Now, I'm no iPhone lover. I'm no Mac lover. I know I'm using one on stage here, but I stole that. No worries there. But the iPhone was a gift because it was the first great lesson that we had in diversity. Because suddenly, these sites that we built that could only work in Internet Explorer or Netscape 4.7 suddenly had to work on a completely new form factor, with a completely new interface, with all different metaphors for how things worked. And it blew our tiny collective minds. And we had to learn about responsive web design. Ethan Marcotte came along and told us good lessons there about how to do things. And the reason we did this is because we didn't want to exclude people. We didn't want people to turn up to our websites and not be able to use them. Sometimes that was because of morality. A lot of the times that was because it was sheer business sense. It's a time that gave us this, the pyramid of robustness, as I like to think of it. When sites had distinct separation of concerns, when we had layers of technology, with the most robust things, the most hardy things, those things that are declarative and could fail really, in only the most extreme circumstances, sitting at the bottom, with the next I've forgotten how to speak English, with the next least robust things sitting on top, in the next layers going up. So the things that are most fragile, sitting at the top there. And it served the web incredibly well for years. This technique worked. Like Jeremy said, it was the silver bullet that fixed things. And it was a good time. It was a really good time for the web. A time of diversity and empathy. When we loved and embraced and accepted that people were different to us. It was the web's summer of love. But, that word but again. Are we starting to repeat this little cycle? We've gone through it at least once now, and are we just trying to enter into it again? Because we've got to the point, haven't we, well, we haven't got to the point. We got to the point at least 2 years ago where the average web page size is about 2 megabytes. This isn't for video or for GIFs or anything like that. This is for basic content sites. The average is 2 megabytes. You might say, whatever, 2 megabytes, Charlie. But if I told you this fact, that 53% of users abandon sites that take more than 3 seconds to load, and then told you that the average site loading time on 3G is 12 seconds, it's a bit of a, what? Oh, okay, I never considered it that way. And again, you might just say, Charlie, whatever, get with it, Grandma. That's just on mobile phones, you know? Well, guess what most of the developing world is on? Most of the upcoming billion people who are going to be using the internet. They're on things like this. This is the Moto G4. This is literally the most average phone on the planet. It's a low processing device, does not run JavaScript easily, and it has got a high latency connection. It does not download things easily. Yet this is the thing that most people are using. And again, you might be folding your arms in this point and be talking about, well, whatever, Charlie, that's like just the Indian and Chinese customers. We don't need them. Goodness, I'm not talking about them, I'm talking about my customers. And I say, okay, right, whatever, you know, Mr. Hypothetical racist person, you know. But what about if you applied this to the USA, for example? A place where outside of metropolitan areas, you are not going to find 3G connections ever. And in fact, I saw one statistic recently that said the average wired connection, you know, to the home for a USA household, rural areas, is 56 kbps dial-up connection. No broadband out there in the countryside, and yet we're building sites as if they needed to be downloaded via fiber connections. We've also got to the point where accessibility is kind of an unknown, isn't it still? I know we all talk about it, we see all the blog posts going out there, but we don't really do it, do we? And you can tell that we don't really do it because we don't put it into our job adverts. How many job adverts do you see where accessibility is the #1 criteria for a developer? 0. And we've got to the point, haven't we, where we've started to kind of think that maybe we should be delivering things by JavaScript as a default, where we should be sending HTML or data over the wire and letting JavaScript handle things in the client for us. And I was going to say here, permission to rant about this issue, but this is my fucking talk and I can rant as much as I want to. To me, this feels like, it's like building a flying car in your garage, isn't it? It's like ordering the kit from overseas and putting it together in your garage and testing it out and then taking it out onto the road and then taking it down the road and taking off and soaring to work and landing in your car park space 2 kilometers away. Wow. That's amazing. I applaud you. That is absolutely wonderful. But wouldn't it have been better to buy a fucking bicycle instead? It's a prime example of how we fall in love with the technical over-engineering so easily, don't we? We're building the sites that we want to build, instead of the things that the user wants to build. And before you get me wrong, I am not talking smack on JavaScript. Believe me, I use it every day. I'm not talking smack on it. I'm not saying that, you know, games like this have to be progressively enhanced, or a drawing application in the browser, or the amazing stuff that Ruth showed us earlier have to be done progressively enhanced. They don't. There's no need to do that. I'm talking about content sites, the medium for which the web was invented. 99% still of what the web is about. I don't know if that's a real number. I'm plucking it out of my arse. But I feel that it's a real number. Because we've got kind of this FOMO, haven't we? We feel that everybody is building a single-page application in the latest framework. And oh my God, that blog post said I should be using this new technology. And I haven't used TypeScript to check all my code. Oh God, I'm a failure. I'm a real failure as a developer, aren't I? But this isn't the reality. The top 15 sites on the planet are basic content sites. Things that you do not need huge amounts of client-side technology to achieve. Yes, even things like YouTube, even stuff like Twitter and Facebook. These are all easily, progressively enhanced. We've got to the point where content sites are suddenly starting to become brittle. Things that used to be robust and amazing are suddenly starting to fail when there's bad network connections, or when the user blocks JavaScript for some reason, which they do, or when an advert spews out bad JavaScript that contaminates your entire page and everything goes down. These things happen. And suddenly we've made pages and sites that are fragile. And it's like we've turned that pyramid of robustness upside down. With the most fragile things, the imperative code that shatters if one byte is wrong, suddenly sitting at the bottom, taking all the weight. I'm no physical engineer, but I know that the Egyptians did not actually build pyramids like this. They are inherently unstable when built like this. It's proven. Science has proved it. Ask me. I work for a scientific publisher. And maybe we've got to the point where we're kind of thinking about resume-driven development a little bit. You know, we kind of base our technology choices upon what's going to look good on our CV, don't we? The word users and user research, that kind of disappeared from our collective vocabulary, and we don't like to think about that. We're back to the point where we're starting to exclude people again. Deliberately, we're starting to say, you groups of users, you can't use my website. You? Okay, you can use my website. All because we want to have our fun. But this is a bit negative, isn't it? I know this is a bit negative. This is kind of what I'm known for now, being the negative Nelly on things. So I'm going to suggest some positive things that we can do. Because there are things we can do now to stop this cycle from kicking in again. And to me, the biggest thing that we can do is to start cultivating a culture of empathy. I have to be really sure I'm saying the word empathy there and not emphasis, which I'm really prone to doing, so I apologize if I get this wrong for the rest of the talk. Empathy is hard. It's really hard to do for people. Despite it being wired into us, somehow society tries to push it out of us. On the other hand, technology, I would argue, is quite easy. You can just go and use your favorite search engine and find out how to do things and build up your knowledge that way. You cannot do the same for empathy. It's something that you have to enact. So I'm going to share just a few tips here, just 5 tips that I find help me to do that culture of empathy and to help me build better websites that work for everybody. And the first one of those is trying to get back to a bit more of a simple technology mindset. Just a little bit. And it's a little bit meta than my other tips here, you know. These others might be a bit more technical. But this one is a bit hippy-dippy, you know. Because I think we need to do this. I think we need to step back a little bit on our rush forward with technology. Okay, I'm seeing some faces there that aren't convinced. So, I've just revealed the actual thing here. Hands up here if you do work for Facebook. No, no one here works for Facebook. Yet, we spend all of our time trying to be like Facebook, don't we? In our technology stacks and the way that we work. We try to be like them. And yet they're an tech-driven, engineering-centric corporate beast who almost allowed the destruction of democracy. And for some reason, we use them as the role model for how we should do things. When we try to be like them, I think it introduces chaos and complexity into a world that is already complex enough. So I say step back from this kind of thing. But how can we make our products more simple? How can we manifest this? Well, there's many ways. And like I said, the best way is to use the least tech possible. God, I really do sound like some kind of, Amish, kind of like least tech possible person. I don't care. I'm going to put that as a selling label on my work from now on. HTML first, or server-side generation, as we like to call it in the old days, is probably the best example of this. HTML generated on the server is 100% inclusive. You don't need any more technology than a basic web browser to do that. It doesn't matter the browser you're using, the age of the browser, the conditions you're in, HTML will work. It's fast. It is incredibly fast. I know we like to talk about sending JavaScript apps over the pipe and hydrating them with data and things like that. But seriously, just send in HTML in the first place. That is faster most of the time. Go look at any of the talks by Ian Feather. Go look at work by people like Netflix, who are just doing server-side generation for things now. They know this stuff is faster. It takes zero processing power on the client. We talked about that Moto G4 up there. This doesn't require any processing power there for it to render things. And it's fundamentally inclusive and fundamentally accessible. Assuming you follow step 2, which is about building with semantics. Because this is a really easy one for us to do. Yet, as we saw again today, people do not do it. People love their div soup, don't they? They love a taste of the tasty div soup. But why do things better? Again, we saw today, you do that because you get so many things for free. You make something that works for everybody, and yet you get so much with it. You get accessibility baked in from the ground up. That's wonderful. What a free gift we have, and yet we ignore it all the time. It is absolutely incredible. You can do this yourself, of course. Like we saw earlier, we could have divs, and we could put ARIA labels on there, and we can replicate things with JavaScript. But again, that is fragile. You're introducing fragility into a system and complexity into a system that you don't need to. And besides which, somebody else has done the work for you. Aren't devs meant to be lazy? That's our kind of thing. That's our constant motif. We're lazy. We like to write less code. Why don't we just accept what the browser gives us most of the time? And the third step in this, I said 5 steps. We're third step here. So we're halfway through. Don't worry. I know I'm standing between you and the pub. Don't worry, we're going to get there. I really want to drink also. Now, this might be unfamiliar to many, this notion of designing and developing progressively. But if you're familiar with things like lean UX, if you've heard of phrases like minimum viable product and agile and things like that, you're probably on the right road with this. And this is something that we do at my company, at Springer Nature. I talked about them. This is actually something we enact all the time, and it's absolutely fantastic. Because it's that layered story again. I keep talking about these layers of technologies building up. Well, you can also apply that to the process of things. So we combine those previous two techniques, simplicity and accessibility, and we start with the absolute minimum. We start with server-side generated HTML. And then we start layering things on top of that gradually. We layer on some, it starts out like this as HTML, then we layer on some really simple CSS, then we layer on some more advanced CSS. And, that's stuff that you can pull from a design system. You can pull in all these little chunks. We're not talking about designing from scratch. We're just talking about proving concepts with the browsers, with the users. Because we test this with users. This, right now. Not the visual designs, not the pretty things. We test this to see if users can use our navigation, if we show them all the data that is necessary for them to use the site. And then we add on these extra things, and we add on stuff like JavaScript and our animations. At each stage that we do this, we have a fully working product that is usable by users, even if it's not pretty. The layers of the pyramid reflected in that design process. And why do we do this? Well, to me, that Bauhaus quote, form follows function, sums it up for us. Because the form should follow the function. The form is the interface, the function, yes, that's the right way around. The function is the HTML that's there. It's the information architecture of a site revealed. And it forces teams, designers and developers to think about content and information architecture first, before the visuals and before the code. It's a really radically different way of doing things. And talking of radicalism, we use similar techniques to make our sites available to everybody. And if I told you that is possible, that you can make your site work with somebody, even if they step out of an Internet Explorer 5.5 powered time machine, oh God, imagine that monstrosity. It is absolutely possible to do this. And how to do this? Well, Chris at the back, who's not paying attention right now, gave us this quote, which was that it's not okay to block old browsers, but it's a waste of time to support them all 100%. No, I didn't. Change your name, sweetheart. That's as far as it is. We don't support them all in the same way. That's our secret. That's what we do at our company. And we use something called cutting the mustard to make that support happen in different ways. And you might have heard about cutting the mustard. That's something that the BBC pioneered years ago, and they've established it and made it work. And we've taken that and used it in a slightly different way. Because like I said earlier, we have those really simple server-side generated sites first. The server-side generated version, HTML first. We take that and we add on a really basic style sheet to it. Incredibly basic, just this. Enough to constrain it in the browser slightly and do some text styling, some minor font changes. But most of the time using native form controls and basic browser font sizing, whatever the browser gives us. And because that's built with semantic HTML and server-side generated first, it works for 100% of users, guaranteed. that works for everybody. But we don't stop there, because I think our marketing people would actually come down like a mighty meteor and destroy us if we tried to launch a site like that. We would be out of a job in seconds. So that's why we use this, which is a media query that allows us to load in the more advanced CSS. You saw it in that example there, where we took more interesting visuals to put on top. And this media query is really amazing because this allows us to select for all the latest browsers, all the modern versions of browsers out there. So things like, and make it look like this, by the way. You know, this is what I'm talking about. And it would select for things like Firefox, Safari, Chrome, all the latest versions of it. Unfortunately, that also includes Internet Explorer 11 because of the media query that we use. But there is a version out there that allows you to do this without including Internet Explorer 11. The reason we include Internet Explorer 11 is because scientists have not figured out how to upgrade their computers yet. And still approximately 6% of our web traffic is Internet Explorer 11. So the business do not like it if we exclude them. And then I talked about layering on JavaScript on top. And you can, just the same way, you can load JavaScript using that media query. And that might be a bit of a, what? You're using CSS to load JavaScript? Well, not quite. We're using something called the Windows Match Media method. And that's something that allows you to feed in a media query and to see if it passes true or false. So we feed in that media query from the page earlier that we used to load. And if that media query passes, you know, if it's a modern browser in some way, the last few versions it selects for, then that means that JavaScript can be used as well. We're confident that the JavaScript can be used. And so we load that in. And this is an incredibly simple and beautiful technique, I think. One that allows stuff to work for everybody. And that's the practical reason for it, really. Because it's partly selfish, yes. We do want to just make our lives easier. We don't want to be supporting different visuals for Internet Explorer 8, you know? Internet Explorer 7, things like that, just because the CEO uses a terrible browser at home. We don't try to do that. It allows us to use things like grid and all those amazing sexy technologies that are coming along, and to use them with confidence in the browser. But the main reason for doing it is because it's for the users. This enables it to work for 100% of users out there, again. And it doesn't cost us anything, it doesn't take a different technique to do, it's just a different mindset, that's all. One that considers users first and does not consider our sites only available for the rich or for the lucky. And you can go check that out. You can go check that out on, if you go not to Google, if you go use your favorite search engine and look for Springer Nature Front-End Playbook, you can find out how we did that. And then the final step, because I've been a bit cheeky here and I've overrun deliberately, but I'm the last one, and again, nobody's going to be late because of me. The final step, test, test, test. Test like the professional you are, because we do love tests, don't we? You know, we love writing tests, we love writing unit tests, and we love writing end-to-end tests and functional tests. But we don't seem to like testing for actual end users, do we? We don't test for them. We test our code, but we don't test for users. And I've seen everybody here today using, you know, things like MacBooks. I can see some of them glowing away now. That's got stuff like VoiceOver built in. There is no excuse for not testing your site with a screen reader immediately. Same with Windows, it's got Narrator built in. Just go and use it now. If you go on Mac, press Command and F5 and get going. Similarly, people need to be testing things with their keyboards. I'm pretty sure everybody here develops with a keyboard, don't you? You have them, test with them, try them out. Just use the tab key and see how your site works. For people who might be using, or might have limited mobility issues, or using a switch device. It's an easy thing to do, easy empathy example. And I was going to say here to throttle your connection and try things out in the dev tools. See how it works for lower speed users. But fuck that, seriously. Just use it with real hardware instead. Start checking your sites on phones that have got cracked screens, that are really low-end devices. Try using it in direct sunlight and see how your site works. Because we tend to assume that if it works on our €3,000 Mac or the €1,000 iPhone that we have in our pocket, that it works for everybody. And that simply isn't true. You have to do this stuff because testing for accessibility in this way is a core part of your jobs, a core part of our jobs. That's what we're there for. We're there to make code that works for users. That's our job. If you want to just play with code, frankly, go and work on the back end, do something there. Our job is about users. Okay, in summary, so I said that the World Wide Web is strong. It's strong because of that robustness and that simplicity of things. Each one of those simple technologies building on top of the other. And as a result of that robustness and that simplicity, it's become essential for everybody. It's become vital to the world. So let's start defending that robustness, enabling that robustness, and therefore enabling it for users. Let's not make it about us. Let's make it for them and the World Wide Web. Thank you.
Go on, get in. Thank you. It was as amazing as it was in my brain when I read that in February.
Well, what can I say?
I'll buy you a beer in a bit.
Oh, thanks, yes!
Cool. So, that's really, really important, going for a beer.
Should I stay here? Should I just go away?
It's up to you. If you want to stand here and help me plug things into my computer so I
why
can
not?
make it work.
See, there you go. No.
Cool. So, today's been amazing. And today has happened because of a number of things. So I do have to say thank you to a few people. So I'm just going to run through those really quickly. We have to say thank you to Squiz because they allowed the screen to work over here. And that screen is powered by some ladies right at the back. And they've done an incredible job. And I really appreciate that. So it may appear that nobody in this room needed that screen, but somebody could have come to this conference and they could have needed that screen. So that meant that we made this place accessible for those people. But what that also means is those people at the back of the room have typed all of those words that have been said today. They're typing them now. I can see them appear. It's amazing. And that means that we can caption every single one of the videos that we've recorded today. So then that means all of the videos that we've got can work on people's phones when they haven't got their headphones. You know, accessibility isn't about just those people who have got a disability. A disability, it could be temporary. And I learned this from this young lady, and she makes me smile every day I see her. But that's another time, another talk, and we'll come to that. We need to thank these people because they helped us provide you with coffee and tea and cookies and whatever it was that you had during the break whilst I was running around looking for the lost microphone. We need to thank these people, because without these people, we would have to charge you more money. And we want to make this event accessible to people who haven't got money, and we've done as much as we possibly can to make that happen. One of the things that we made to do that happen is, I'm going to try and do something really weird now. So above you, up in the sky, there are two guys that have been submitting this. Oh, wow. And I was, yeah, come on, where is more of me? That one's behind. Anyway, so they've been pushing this out to everybody out in the world, because that's what the web is good at. We can publish content to anybody, and we don't care who they are or where they are or how much money they've given us. I know for certain that... hello, Ree. Oh, wow. This is amazing. I know for certain that my friends that I work with in Australia have been watching this as well, because I've received tweets today saying, Dave, that talk was amazing. So, thank you to those two guys up there. They've been here since 7 o'clock this morning. Nick arrived before I did. Anyway. I'm nearly done. So thank you to all of our speakers, because without them we wouldn't have had any content. They're all here, they're all in the room, they're all going to go to the pub, and you can talk to them, you can buy them drinks if they would like a drink. That's entirely up to you. If you've had something to say, make sure you leave any feedback in one of those boxes if you want. There's the other 5 speakers. They're not in any particular order other than via alphabets. So, yeah, if you've filled out one of those things, put it in a box, and we will make sure that that information gets to the speakers so that they can smile and feel glorious inside because of the great work that they did today. These people help make sure that we could put on this place a cheaper amount than I like to think every other conference that's paid for, but I don't know. And these people made sure that some people could come here today for free. Cool. I want to thank the people who helped me organize this as well. I know for sure that somebody has been sat at the back of the room, and every time one of our speakers referenced something, it appeared on their speaker page. So if I go and show you, for example, Michelle's speaker page, every link that she referred to appears on that page. And that was done in real time this morning, and thank you to Chris for doing that. Thank you to Matteo for taking photographs and helping do GitHub-y things, and awesome. Thank you to Morena and Janestra. She's probably still sat outside watching the live stream, so thank you for that, because otherwise one of our organizers would have missed all of this. Cool. It's me again. Pub, anybody? Chris is waving at me because I don't know why. In order to make this cheaper for next year, please can we have the lanyards back? You can keep the little card thing, and there's some boxes at the end. That makes it cheaper for us next year, so we don't have to put on it, because these things cost us money, and it means we can spend it on cookies or something like that. Please take away the fruit and the water and everything else, and we'll see you at the pub. It's called Craft Beer Co. Amazing beers. They also do non-alcoholic drinks. We've got a little bit of tidying up to do, but we'll be there as quickly as we possibly can. We'll see you soon. And we'll see you next year.